NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams. The largest telescope ever flown launched into deep space on Christmas Day 2021. Its primary mission is to reveal the "let there be light" moment, when the stars and galaxies first ignited after the Big Bang. Recently, we got a look at some captivating images as Webb peers back toward the origin of everything. This is one of Webb's early deep dives into the cosmos. 250 hours of exposures that expand the imagination. And all these little dots are stars?
All these little dots are galaxies, some of which are bigger than our own.
Astrophysicist Brant Robertson flew us through 130,000 galaxies, half never seen before, enormous swirls of billions of stars each, some like our own Milky Way, and others, well, out of this world.
We call this galaxy at the center of the screen the cosmic rose. Just by chance, it looks like a rose does. You can see that dusty red irregular galaxy. You know, space is more crowded than you might think, and actually galaxies wind up interacting with each other. They actually will merge together. So I'm zooming in now on a pair of galaxies that are merging together, interacting. You can see that they're disturbed because the gravity of one galaxy yanks the stars out of the other galaxy.
They're running into each other.
They're running into each other.
Robertson of the University of California, Santa Cruz, helps lead Webb's most ambitious mission, the Advanced Deep Extragalactic Survey.
Well, we've discovered the most distant galaxy in the universe, the one that is the furthest away from us that we currently know about. I'd like to share that with you. Can I show you some pictures of it?
I'd love to see it.
So as we zoom in, we keep going, and now this red splotch that you see there, that galaxy, that's a galaxy. That galaxy is more than 33 billion light years away.
How long after the Big Bang, the beginning of the universe, did this galaxy form?
It's amazing. It's only 320 million years after the Big Bang.
The most distant galaxy so far, there on the right, doesn't look like much, but astronomers can fill textbooks by analyzing the spectrum of its light.
So we can actually measure things like how fast it's forming stars. We can measure the amount of stars in the galaxy. We know the size because we know how far away it is. And we know the typical age of the stars in the galaxy. So we know a lot.
The earliest galaxy so far formed when the universe was 2% of its current age, and the baby galaxy ignited stars at a furious pace.
It's like a hummingbird. You know, the heartbeat of this galaxy is so rapid.
What do you mean by that?
Well, this galaxy is forming stars at about the rate of the Milky Way, even though it's 100 times less massive. So it really is like a hummingbird. The heartbeat of this galaxy is racing.
T-minus 30 seconds and counting.
More than a few human hearts were racing in 2021 as the $10 billion observatory readied for launch. Wow. Earlier that year, we were among the last to see Webb in California before it was folded into a 15-foot wide nose cone. Well, somehow that's a lot bigger than I imagined. 25 years in the making, Webb is named for an early NASA administrator. Northrop Grumman engineer Amy Lowe showed us down below the silver-colored sunshield, big as a tennis court, and 21 feet of gold-plated mirrors for gathering light. There are 18 of these hexagonal mirrors, but when you fold them out, they all work in concert as one mirror.
That's right. All 18 images will form one very solid image.
And liftoff. Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
Webb lofted on a European rocket into an orbit around the Sun 1 million miles away. To set up for observations, engineers used a star to align those mirrors, but the image was speckled with what looked like artifacts of digital noise, which forced a closer look.
These were not artifacts from the detector. These were not strange stars. The whole of the sky was filled with galaxies. There was no empty sky. And that's when I went, this telescope's going to be phenomenal.
Matt Mountain leads Webb's operations as president of the Association of Universities for Research in Astronomy.
No empty sky. What do you mean by that?
And almost every image we're taking now, we see galaxies everywhere. I mean, we took a simple picture of a planet in our own system, Neptune. You know, it was this beautiful orb just sitting there, and we saw some rings. And the background are galaxies again. It tells us that our universe is filled with galaxies. We knew this theoretically, but when you go out to the night sky, we're used to saying, well, look up the night sky, we see those stars. We can no longer say that. We now have to say, look up at the night sky, and there are galaxies everywhere.
We call it space because we thought there was nothing out there.
There is no empty sky with James Webb. That is what we have discovered.
Matt Mountain says that Webb is a reminder of how much we do not know. For example, galaxies are rushing away from each other at greater and greater speed, defying gravity. It makes no sense. So scientists infer that there must be unseen elements at work. They call them dark energy and dark matter.
And whenever you hear the term dark energy or dark matter, this means we don't know what it is. We're not that imaginative. But it is a force. It is 95% of our universe, and we have no idea what it is.
Wait a minute. 95% of our universe is made up of dark energy and dark matter, and we don't know what it is.
Correct. We're lucky if we even understand 4% of our universe today. Astronomy is a very humbling discipline.
Humbling, but with Webb,
Look at this.
also thrilling.
Look at this. Right.
This is Purdue University astronomer Dan Milisavljevic, starstruck and chatting with a colleague.
Yes. Yes. Look at the detail.
Even Wilbur, who's not an astronomer, strained to see what the excitement was about. Milisavljevic studies exploded stars, which were the furnaces that forged the first heavy elements from a cosmos of simple helium and hydrogen.
Every time there's a supernova explosion, it's producing the raw materials for life. The iron in our blood, the calcium in our bones, the oxygen that we breathe. Love that oxygen. All that is being manufactured in supernova explosions.
The late astronomer Carl Sagan used to say we're all made of star stuff.
That's exactly right.
Webb reveals unprecedented detail at the center of these explosions.
And that's what Webb is most sensitive to for our purposes. Understanding what's happening inside the explosion that we couldn't see before because it only comes out in infrared light.
Infrared light is what Webb is designed to see. Like a night vision camera, the telescope is sensitive to heat radiation, which is all that remains of the light reaching us from the dawn of time. Trouble is, infrared is invisible to the human eye.
When you first pull up the Webb data, what does that look like?
Essentially, it looks like a blank screen.
Elisa Pagon and Joe DePasquale are astronomers and science imagers for the Space Telescope Science Institute. This is what a Webb infrared picture looks like until they match the data-filled darkness to colors of wonder.
So we take those longest wavelengths of infrared light and give those the red colors. The next shortest wavelengths would be green, and then the shortest wavelengths that we get from Webb are colored blue. And so just like how our eyes work, we take those three color channels, combine them together to create the full color images that we see from Webb.
Among their favorite images is this cluster of stars with the not-so-wondrous name NGC 346. cosmic dust sculpted into ripples by interactions between stars, and the Tarantula Nebula, a star-birthing nursery on a backdrop of galaxies.
It occurs to me you're the first two people to see these images in human history.
Yeah.
It's quite an honor.
It is a great honor, and it does blow your mind every time.
There will be many mind-blowing revelations. Webb is already the first to find carbon dioxide in the sky of a planet 700 light-years away. It will continue to look for planets with atmospheres that might support life. On the other end of the time scale, astrophysicist Erica Nelson of the University of Colorado Boulder thinks her team may have made a discovery that she says would break the theory of how the early universe formed.
Either this is wrong or this is a huge discovery. And we think that it's a huge discovery.
More observations are needed, but Nelson is investigating what may be 5 giant galaxies that appear to have formed much too quickly after the Big Bang. If they're confirmed, astronomy may have to revise the timeline of galaxy formation.
And that's the most exciting piece of this telescope, of this remarkable instrument we put in space, is finding things that we didn't expect, that we can't explain, because that means that we have to revise our understanding of the universe.
Brant Robertson, who showed us the earliest galaxy found so far by the James Webb Telescope, told us the record for the earliest will not hold long.
How far back can you go to the origins of the universe?
Well, JWST is so phenomenal that if you spend enough time, you could probably find any galaxy that ever formed in the universe. It's really that powerful.
Will the history of astronomy be divided between before Webb and after Webb?
Yes, I believe it will be.
Matt Mountain, who manages Webb operations, told us the observatory may last up to 25 years, perhaps long enough to comprehend space and time and the origins of life.
We're seeing a universe we've never seen before. We thought it was there, we hoped it was there, but now we see it for the first time.
When we look up at the stars, it's humbling to realize we're only getting a peek at what's up there, that way beyond what's visible to the naked eye lie wondrous galaxies we never knew existed until the Hubble Space Telescope. For 27 years since it was launched into space, Hubble has been sending us stunning images of the vast heavens. Over the years, astronauts have repeatedly upgraded Hubble, so its most dramatic discoveries have come recently. Tonight, we'll take you up to Hubble and billions of light years beyond to see some of its latest, most spectacular revelations. NASA celebrates Hubble's birthday each year by giving us a gift, a new, breathtaking view of our universe. The latest birthday card, this elegant swirl of galaxies dancing in tandem deep in space. Last year, this bubble of stellar gases floating among the stars like a diaphanous cosmic jellyfish. Hubble has shown us radiant, rose-shaped galaxies stretching across deep space, and dramatic, towering clouds of gas teeming with the stuff of creation. Stars are born here. Year after year, in the infinite black canvas overhead, Hubble paints an ever-expanding picture of our universe, an awe-inspiring light show for us to admire and for scientists to study.
I believe Hubble has been the single most transformative scientific instrument that we've ever built.
Most transformative, says NASA astrophysicist Amber Strawn, because Hubble keeps improving our understanding of the universe. She showed us what Hubble discovered after staring for days into what seemed to be an empty black patch, a deep, dark void in outer space.
The original Hubble Deep Field is located just above the Big Dipper. It's a part of the sky that most people are familiar with. It's a blank piece of sky.
So just nothing in here, just darkness.
Nothing at all, complete darkness. And then when we look at it with Hubble, what we see is thousands of galaxies.
Not just stars,
right.
Galaxies.
Galaxies outside of our own, something we never imagined.
Is it that Hubble just stares into that dark spot until the light penetrates and reveals itself?
That's exactly what happens. It's sometimes many, many, many days of just staring at one part of the sky and allowing the photons to collect on your detector.
And this is what's revealed.
And this is what's revealed.
But Hubble was just warming up. That was 22 years ago. Since then, Hubble has stared deeper and longer into space with enhanced equipment.
In this particular image, there are 10,000 galaxies. So every single point of light is an individual galaxy, its own little island universe. And so this is a real visualization of the distances of these galaxies. So sort of like
3D.
3D, like we're flying through. So we can make these images 3D because we know how far away the galaxies are. What Hubble has essentially given us is the size of the universe. Hubble has taught us that the universe is filled with hundreds of billions of other galaxies.
And now the latest analysis of Hubble's data reveals there could be more than 2 trillion galaxies, 10 times more than previously thought. Typical galaxies, like our Milky Way, have 100 billion stars. That means the total number of stars or suns out there is 2 followed by 23 zeros. That's called 200 sextillion. To get some sense of how many stars that is, we went to Adam Rees, who won a Nobel Prize for his work on Hubble.
This is more stars in the visible universe than grains of sand on the beach.
On Earth.
On all the beaches on Earth.
And Hubble has shown us this?
It has. In many cases, it has allowed us to see what some of the most distant galaxies look like and how many stars were in them, and we've been able to add it all up.
Hubble has been called a time machine, that it looks back in time. What has been the most astounding part of that for you?
I study explosions of stars called supernovae. It's like fireworks. It's only visible for a short period of time, in this case, a few weeks. And that light has been traveling to us for 10 billion years. It began its journey when the Earth wasn't even here. And over those 10 billion years, our planet formed, life developed, we built a Hubble Space Telescope, we opened the aperture door, and in the last 1/billionth of 1% of that journey that the light made, we opened the door just in time to catch it.
Hubble almost didn't catch anything. The first pictures it sent back were blurry because of a microscopic flaw in the mirror. The space agency launched a daring mission to fix it. Astronauts have made 5 trips to Hubble to repair and upgrade its equipment.
Okay, John, you can open the thermal cover.
John Grunsfeld, known as the Hubble repairman, flew 3 of those missions to a telescope the size of a school bus orbiting 300 miles above Earth.
Just about anything that we can easily change and upgrade and fix has been fixed.
The workings of the telescope, all of that has been transformed.
Yep. It is like a new telescope.
On your last mission, you come out of the airlock and you've got this big smile on your face.
I thought, I can't imagine anywhere I'd rather be than outside the space shuttle in my spacesuit next to the Hubble Space Telescope. I was just so happy.
Hubble has changed what we know about the universe, its structure, evolution, its age, 13.8 billion years. Hubble showed us the marvel and majesty of stars being born.
This is a region of gas and dust that's churning up new baby stars. And now we've learned with Hubble not only stars, but also baby planet systems.
Most of these stars have planets going around them?
Most stars actually do have planets. When I was a kid, we only knew of the planets inside our solar system. And now we know that the planets are absolutely everywhere.
Astronomer Heidi Hammel specializes in Hubble's work within our solar system. With the telescope, she saw huge fragments of a comet slam into Jupiter, creating giant impacts.
When I first heard that a comet was going to hit Jupiter, my reaction was, so what? Jupiter's huge, comets are small. And so when I saw the first impact site, and it was huge and dark. I was flabbergasted. This is where the comet has smacked into the planet at such a high velocity that it's caused an explosion, the equivalent of many, many millions of atomic bombs. The Earth is the size of that ring. And so if this event had happened on Earth,
we're gone.
Yeah, we call that a biosphere-changing event, which basically means we'd be gone.
Hubble orbits high outside Earth's atmosphere, so it can see a wide spectrum of light our atmosphere blocks. Beyond Earth's protective layer, Hubble's ultraviolet camera can spot dazzling displays like this glowing halo on top of Jupiter.
Up in the northern hemisphere, what you're seeing is the glowing aurorae. An aurora happens when the planet's magnetic field has charged particles that interact with the upper atmosphere. What you're seeing there is actually charged particles from the sun. They get swept up in Jupiter's strong magnetic field, and then it's mirrored in that shimmering that you see inside the auroral oval.
And you would not be able to see that with an Earth telescope?
You could never see those aurora because our atmosphere has an ozone layer that absorbs the ultraviolet light.
Hubble also found a similar blue hue at the bottom of Saturn. The telescope's most iconic picture is this, the Pillars of Creation, a stellar breeding place. Amber Strawn showed us what a difference Hubble's upgraded infrared camera made just 2 years ago.
Stars are born inside these dust clouds. And this is going to give you a clue on why infrared is so important. It's because in infrared light, what you see is the stars inside.
See the stars inside. Look
shining
at that.
through.
How big is this cloud area?
Top to bottom, these pillars are about 10 light years, which is about 60 trillion miles.
60 trillion miles.
Yes. Space is big.
Big and miraculous, with constant celestial regeneration. Strawn calls this the everything picture, because you can see old stars blowing up and new stars forming.
Anytime you see these sort of dark, cloudy regions, you can imagine that there's stars being born inside there.
Where are the dying stars?
And the dying stars, we think that this one could explode any day, literally, or it could be 1,000 years from now, but near term in astronomers'
cosmic time, it's any day.
Right. So big stars, when they die, they explode and send their contents into the surrounding universe. And these contents are what seed future stars and future planets and help to seed life, ultimately. The iron in your blood and the calcium in your bones was literally forged inside of a star that ended its life like this.
So we are all stardust.
We literally are stardust. We are viscerally made of the stars. One of the things I think is remarkable about this image is it shows you how colorful the universe is.
This looks like contemporary art.
This is a very tightly bound group of stars. And what you see here is about 100,000 stars. This was one of the first images that Hubble's new camera, installed in 2009, this was one of the first images it took.
Blue stars are the youngest and hottest. White and yellow stars, like our sun, are midlife, while red stars are the oldest and coolest.
What a beautiful view.
John Grunsfeld has a cool claim to fame. He's the last human to touch Hubble. He gave it a farewell pat. Hubble was planned to live for 15 years. It's now been 27. How much longer can Hubble go?
I'm reasonably confident it will continue another 3 to 5 years.
That means, for a while at least, Hubble will work in tandem with its successor, the much larger James Webb Telescope, scheduled to launch in 2019. Webb should be able to detect light from the very earliest galaxies. The farthest back Hubble can see is this red blob, a galaxy from 400 million years after the Big Bang. Webb should take us much closer to the beginning of time.
So the James Webb Space Telescope was specifically designed to see the first stars and galaxies that were formed in the universe. So we're going to see the snapshot of when stars started, when galaxies started, the very first moments of the universe. And my bet, there's going to be some big surprises.
In the history of spaceflight, only 4 entities have launched a space capsule into orbit and successfully brought it back to the Earth: the United States, Russia, China, and Elon Musk. Mr. Musk is a wealthy internet entrepreneur who has vowed to revolutionize space exploration by bringing down the astronomical costs. And that can't happen fast enough for NASA, which retired the Shuttle last summer and now has to pay its old rival Russia to fly American astronauts into space. Musk is one of the contenders vying for a NASA contract to build America's next manned spacecraft, a contest he believes he has the right stuff to win. When the final shuttle mission ended last July, for the first time in 3 decades, the United States had no way to launch astronauts into space. It was the end of one era and the beginning of another. Instead of NASA designing the next manned spacecraft, the White House decided that private industry should design, build, and fly it, opening space to commercial development. One of the companies vying for that contract is SpaceX. Elon Musk is the founder and CEO. Is what we are experiencing at this moment in time the turning point in man's reach for space, going from governments to private companies like yours?
I think we're at the dawn of a new era, and I think it's going to be very exciting. What we're hoping to do with SpaceX is to push the envelope and provide a reason for people to be excited and inspired to be human.
Musk is 40 years old, a naturalized American citizen, and reportedly worth nearly $2 billion. He isn't your typical corporate CEO. As a teenager, he wrote computer games in his native South Africa before immigrating to the U.S. and to Silicon Valley, where he was one of the most successful internet entrepreneurs, the co-founder of PayPal.
Ladies and gentlemen, Mr. Elon Musk!
Despite a chorus of skeptics, Musk built a car company called Tesla that turns out 5,000 high-end all-electric cars a year. Another Musk company sells solar power systems. But his lifelong passion is space. And when eBay bought PayPal in 2002, Musk started looking for ways to launch his new fortune into orbit.
I went to Russia to look at buying a refurbished ICBM, which is a very trippy experience. It was very bizarre. And when I tell people that, they're like, what?
Musk made 3 trips to Russia trying to buy an intercontinental ballistic missile called the Dnieper. His plan was bizarre: put a greenhouse on the rocket, land it on Mars, and beam back the pictures.
It'll get people really excited, and that would recharge human space exploration. That was my original idea.
You just wanted to get people interested in space again?
Yes, yes.
Capture the imagination?
Yes, that was the idea.
Turns out the Dnieper was so expensive, his idea never flew. So Musk decided that the only way to get an affordable rocket was to build it himself. And he started SpaceX.
The odds of me coming into the rocket business, not knowing anything about rockets, not having ever built anything, I mean, I would have to be insane if I thought the odds were in my favor.
Why even begin?
When something is important enough, you do it even though the odds are not in your favor.
How much of your personal fortune have you poured into this?
$100 million.
$100 million into something that you did not believe would work at the beginning?
Yes.
Musk truly believes that low-cost space exploration is essential to the survival of mankind.
I think it's important that humanity become a multi-planet species. I think most people would agree that a future where we're a spacefaring civilization is inspiring and exciting compared with one where we are forever confined to Earth until some eventual extinction event. You know, that's really why I started SpaceX.
SpaceX is housed in a sprawling factory near Los Angeles where fuselages for Boeing 747s used to be built. From its beginning 10 years ago, its goal has been revolutionary change in rocket and spacecraft manufacturing. Now, tell me, what's that big piece right up there?
That's the second stage of a Falcon 9 rocket.
Instead of multiple companies building parts all across the country, SpaceX builds most of its rockets and spacecraft in-house, based on Musk's belief that it's more efficient and lowers costs. 1,400 engineers and skilled technicians work here, building engines, rockets, space capsules, creating mostly from scratch the thousands of components that are the guts of a rocket.
So what that means is raw metal comes in, and then we build the engines, the airframe, the electronics, and we integrate all of that together. And that's all done more or less under one roof.
Metal comes in one end of this factory.
Yeah.
Spaceships come out the other.
Yes.
Final assembly takes place at the Cape Canaveral launch pad.
If the margin's there and we don't then have margin to the fourth power, then it's fine.
Musk has college degrees in business and physics, but SpaceX is his first venture in aerospace. He bills himself as chief designer and chief technology officer. How did you get the expertise to be the chief technology officer of a rocket ship company?
I do have a physics background. That's helpful as a foundation. And then I read a lot of books and talked to a lot of smart people.
You're self-taught?
Yeah. Well, self-taught, yes, meaning I don't have an aerospace degree.
So how did you go about acquiring the knowledge?
Well, like I said, I read a lot of books, talked to a lot of people, and have a great team.
His team is a mixture. There are newcomers, mostly 30-something engineers, some of them straight out of college, and then there are the skilled technicians and aerospace veterans. Former NASA astronaut Garrett Reisman spent 3 months aboard the space station and flew on one of the final shuttle missions. He was brought in to help oversee the company's manned space work. You know, I'm curious, you have so much background in engineering. You could have easily gotten a job at Boeing or at Lockheed, but you came here.
If you had a chance to go back in time and work with Howard Hughes when he was creating TWA, if you had a chance to be there at that moment when it was the dawn of a brand new era, wouldn't you want to do that? I mean, that's why I'm here.
And that's why most of the engineers we met are here. Building spaceships is the chance of a lifetime. If you reach the point of having a successful manned flight, what will you have proven?
We're not doing it to prove anything. We know it can be done. We're just trying to do it a little bit differently, a little bit faster, and to push the fence a little bit farther out.
And then we can all go. I mean, I want to go into space. I assume most people here do as well.
How many want to ride? Okay. Everybody wants to go.
I'm not so sure.
First stage engine sequence initiated.
3, 2, 1.
4 years after starting, SpaceX rolled out its first rocket, an unmanned booster called the Falcon 1.
Falcon has cleared the tower.
But the first 3 test flights failed to reach orbit.
We are hearing from the Launch Control Center that there has been an anomaly on the vehicle.
When you had that third failure in a row, did you think, I need to pack this in?
Never.
Why not?
I don't ever give up. I mean, I'd have to be dead or completely incapacitated.
It turned out that the third failure was caused by a 2-second glitch in the timing. 8 weeks later, Musk bet the company on another flight.
We have liftoff.
And this time around, everything worked.
Perfect.
If that fourth launch hadn't worked, that would have been it. We would have not had the resources to mount a fifth.
You couldn't have gone out at that point.
Yes, death would have been, I think, inevitable because we did not have the resources to mount a fifth launch.
This is a tricky business.
Tricky. Yeah, yeah, I wish it wasn't so hard.
In 2010, SpaceX tested a larger, more powerful 9-engine rocket called the Falcon 9 and an unmanned cargo capsule known as Dragon. It was the first privately developed rocket designed to carry cargo and eventually astronauts to the space station.
MVAC ignition confirmed.
3.2 kilometers per second.
In its first test flight, the Dragon capsule performed flawlessly, orbiting the Earth twice before splashdown in the Pacific, the first time a private company had launched and recovered its own spacecraft. And this is a historic spacecraft.
Yeah, it is, yeah.
We came across the Dragon capsule while Musk was showing us around.
You know what I noticed about your cargo ship is that it has windows.
Yeah, absolutely. The windows are there in case there's an astronaut on board who wants to look up.
But people don't put windows in cargo ships.
That's right, exactly.
So what that tells me is that this was never intended to be only a cargo ship.
No, the Dragon was always designed to carry astronauts.
Musk says a manned version of the Dragon capsule will be safer than the space shuttle and a lot cheaper. Engineers are already designing escape rockets, life support equipment, and computer guidance systems. They were studying seating for 7 when we were there.
Do you believe that your rocket will be the next American rocket to take an astronaut into space?
I believe that is the most likely outcome, yes.
That sort of confidence has not exactly endeared him to the space establishment or to his competitors.
There are people who've been in the rocketry business for decades who say about you that you don't know what you don't know.
Well, I suppose that's true of anyone. How can anyone know what they don't know?
But when critics say you can't do this, your answer to them is,
we've done it.
He's done it in partnership with NASA, which has given SpaceX technical advice and a contract worth up to $1.6 billion, mostly for 12 cargo flights to the space station. But SpaceX's lack of experience bothers some NASA legends like Apollo astronauts Neil Armstrong and Gene Cernan. They've testified to Congress that the Obama administration's drive to commercialize space could compromise safety and eventually cost the taxpayers.
Now is the time to overrule this administration's pledge to mediocrity.
You know, there are American heroes who don't like this idea. Neil Armstrong, Gene Cernan have both testified against commercial spaceflight in the way that you're developing it, and I wonder what you think of that.
I was very sad to see that because those guys are, those guys are heroes of mine, so it's really tough. You know, I wish they would come and visit and see the hardware that we're doing here. And I think that would change their mind.
They inspired you to do this, didn't they?
Yes.
And to see them casting stones in your direction.
It's difficult.
Did you expect them to cheer you on?
So they're hoping they would.
What are you trying to prove to them?
What I'm trying to do is to make a significant difference in spaceflight and help make spaceflight accessible to almost anyone. And I would hope for as much support in that direction as we can receive.
President Obama made his support clear when he visited SpaceX's launch site just before Falcon 9's first test flight. As this animation shows, Elon Musk's next flight will be far more ambitious, carrying cargo all the way to the space station. It was scheduled to fly in February, but it's taken longer than expected to perfect the flight software. The flight will be a complicated rendezvous with a space station that is moving 17,000 miles an hour, 240 miles above the Earth.
Okay, so it looks like our burn performance is nominal.
In the SpaceX mission control, flight simulations are continuing, and if all goes well, SpaceX will begin routine space station cargo deliveries later this year. But the big prize is winning the NASA contract to build America's next manned spacecraft, and Elon Musk is facing stiff competition.
I'm probably not the guy that most people would bet on.
Who wins?
It's like a little kid fighting a bunch of sumo wrestlers. Usually the sumo wrestlers win. We're a little scrappy company. Every now and again, a little scrappy company wins. And I think this will be one of those times.
"12 American men have walked on the moon. The last Apollo astronaut left his footprint there in December 1972. Now, a half-century later, NASA is planning to send people back to the moon. The new program is called Artemis, after Apollo's mythical twin sister. And the goal is that the next footprint on the moon will be made by a woman. The astronaut who gets that assignment hasn't been chosen yet. As you're about to see, this new push to the moon has been plagued by doubts, cost overruns, and delays. But we found something else interesting when we visited NASA. The Artemis program isn't just named for a woman, it's largely being run by women.
So there's no place on launch day that I would want to be but right here.
Charlie Blackwell Thompson is NASA's first female launch director.
And launch director copies.
In a year or so, she'll give the Go for Launch command for the first Artemis moon rocket in historic Firing Room 1 at Kennedy Space Center, which she first visited more than 30 years ago as a college graduate interviewing for a job.
It's the same room that the Apollo 11 mission was launched from, and it is the same room that we will launch the first flight of the Artemis missions.
When that young woman walked in here for the first time, did you truly say to yourself, I want to do this one day?
I absolutely did. My thought was, how do I get a seat in this room?
And now you have the seat in the room.
I have a pretty nice seat in this room.
All the Apollo moon missions were launched atop huge Saturn V rockets. At the time, the most powerful in the world, NASA's new rocket is even more muscular. Can you put it into words how powerful this new rocket is?
The core stage will have hundreds of thousands of gallons of propellant, over 8 million pounds of thrust at liftoff.
The most powerful rocket ever is called the Space Launch System, or SLS. In development for a decade, it has yet to fly and has only fired its 4 main engines once in a test.
It is hard work cheating gravity.
Jody Singer is another female first for NASA. As the first woman to run Marshall Space Flight Center in Alabama, it's been her job to build the SLS, which is designed to go to the moon and beyond.
It is built for going to deep space. And right now, it's the only vehicle that exists that can carry the Orion and take what it does to be able to go to deep space.
The Orion is the capsule that astronauts will ride on top of the SLS rocket. The first one is ready to go. The lunar lander is still in the concept stage, but NASA doesn't really need it until the third Artemis moon mission.
Artemis 1 is about testing out this integrated vehicle, SLS with Orion. Artemis 2 is about the incorporation of the crew and preparing us for Artemis 3, where then we will go to the surface of the moon.
Do you hear yourself? You know how cool that sounds?
It does sound pretty cool.
Another cool piece of the Artemis plan is a space station called Gateway, meant to orbit the moon. NASA intends to use Elon Musk's company, SpaceX, to launch Gateway's components on one of its Falcon Heavy rockets. The Falcon Heavy is already flying. Its first launch sent Musk's Tesla Roadster towards Mars a couple of years ago. Yes, that really happened. Jody Singer says SpaceX is an illustration of NASA partnering with commercial launch providers.
We work together, and I think working together, that is how we will be able to deliver on the Artemis program. We both bring great things on this partnership.
When that partnership will actually deliver women and men to the moon is uncertain. Donald Trump set 2024 as the goal. That was seen by insiders as unrealistic. President Biden hasn't set a timetable, but his White House has given the idea of Artemis an early thumbs up.
Another man and a woman to the moon, which is very exciting.
What does it say about NASA that you are in these positions in what used to be a totally male-dominated sphere?
Well, number one, I'd say we've come a long way. You know, Charlie and I, we know we've known each other for at least 20 years. We liked each other, but also we were, sometimes the only women in the room.
Not anymore. Charlie Blackwell Thompson says that on launch day, 30% of the engineers in what's now her firing room will be women. Have you always been interested in space, when you were a little kid even?
I remember the last Apollo missions, the last couple. And I can remember this sense of curiosity and awe. I could go outside and I could look up at the sky, and that our astronauts were visiting the moon.
The pool of 18 Artemis astronauts has already been chosen. 9 women, 9 men, 6 of whom are test pilots. 4 have PhDs, 3 are medical doctors. It's not known yet which of them will fly to the moon, but 2 are in space right now on the International Space Station. Why the moon? Why put out the expense to return to the moon?
We are still learning from the samples that were returned during the Apollo program. There is so much science, so much scientific discovery to come from returning to the moon.
Scientists are especially tantalized by recent evidence that there's a lot of ice near the moon's south pole. That's exactly where Artemis is meant to land. Ice means H2O, which means water to sustain life and hydrogen and oxygen to potentially turn into rocket fuel.
I would point to the moon being a proving ground, a waypoint for us to learn how to live in deep space when we're only days from home versus months or years for destinations like Mars.
And it will be great when we go back, and we especially will be great if we this time can stay.
Laurie Garver was the number 2 official at NASA during much of the Obama administration. She wants America back on the moon, but believes the current approach is the wrong way to get there.
I would not have recommended the government build a $27 billion rocket when the private sector is building rockets nearly as large for no cost to the taxpayer.
Ignition. She's talking about rockets like Elon Musk's Falcon Heavy.
There it is.
Garver was an early advocate of turning all the development of big new rockets over to private companies like SpaceX.
But the Congress had a different goal. Their goal was really to extend the contracts and jobs in their districts.
At the time, 2010, the Space Shuttle was about to be grounded.
Touchdown.
And members of Congress feared that aerospace jobs in their districts would go away too. The SLS, the Space Launch System, is mockingly referred to as the Senate Launch System. Can you explain to us why it's got that nickname?
In this case, it was the Senate who came to us at NASA and said, no, we don't like your plan, and we are going to make you build it this way.
So Boeing, prime contractor for the Space Shuttle and longtime NASA partner, became the prime contractor for the SLS.
The industry said they would do it for $6 billion in 6 years. That was the rocket. It's been $20 billion in 11 years.
NASA's Jody Singer acknowledges the delays and cost overruns, but insists it's the right model.
The Space Launch System, I'm proud to say, has work that's over 45 states and over 1,100 vendors. So the Space Launch System is a national vehicle. That means jobs. That means that across the nation, for the SLS alone, there's over 25,000 people that have jobs.
It's ironic, honestly, that NASA, the very symbol of a democratic and capitalist society, has done a lot of its human spaceflight programs in more of a socialist way.
More in a socialist way. I think many of the senators whose districts are getting these NASA jobs would balk at that description.
You will plant the potatoes in March. You will build your rocket in my district. That's what it is.
The top-down approach, Garver says, has produced a NASA SLS rocket that'll cost more than $2 billion for every launch.
Falcon Heavy is headed to space.
While SpaceX flies its Falcon Heavy for a fraction of that. NASA's SLS can launch a heavier payload, but it's a use-it-and-lose-it rocket. None of its parts can be reused. By contrast, SpaceX booster rockets make soft landings after launch, so they can be used over and over. 2 of its first stages have already been launched 8 times each. Am I missing something in saying that this is the new way and what's going on with NASA is the old way?
Well, I probably wouldn't characterize it as the new way and the old way. I would probably characterize it as just different ways. I would say that our rocket was designed based on proven technology.
So you wouldn't say it's old, it's proven.
I would say it's proven.
Still, the SpaceX rockets are proven enough
Godspeed, Spot and Dog!
that NASA now trusts them to carry its astronauts to the International Space Station.
Welcome to the space station.
Those successful missions should not be confused with an entirely new rocket called Starship that SpaceX is testing in Texas. 3 test flights so far, all 3 ending in spectacular explosions. The latest one just last week. So should NASA pivot and start relying on SpaceX and commercial launchers for the moon and beyond?
Undoubtedly. We should have before now.
Is NASA capable of making that shift?
Oh, of course. I mean, NASA is capable of more than they realize.
Now, considering all you have told me, will Congress let NASA make that shift?
Probably not.
For the moment, the core stage for the first Artemis mission sits in a test stand in Mississippi, the same stand used for the Apollo missions. It's awaiting a test firing after technical glitches cut the first one short.
And we got to shut down.
There are 6 American flags on the moon, 1 for each Apollo landing. But the newest flag there is Chinese, left last year by a robotic lander that collected samples and brought them back to Earth. Beijing eventually plans to send astronauts. Aren't we in a space race with China?
There's not a race to go to the moon. We won it. We won it 6 times. And I have no doubt that we will be back again with people before anyone else goes.
And Charlie Blackwell Thompson will be the woman to launch them from her seat in the firing room.
We talk a lot about the moon, and I think the moon is phenomenal, and I can't wait to go back. But when we talk about those young people that may be like me when I was younger, looking up at the night sky and looking up at the moon, I want them to look up at the night sky and not be limited to the moon.
A small robotic lander built by a private company and carrying a scientific payload for NASA touched down near the south pole of the moon 11 days ago and promptly tipped over on its side. Even so, it's the first American spacecraft to land on the moon in more than 50 years. NASA has a much more ambitious lunar program called Artemis, which aims to send people back to the moon to establish an outpost at the South Pole and to push on from there to Mars. We previewed Artemis here in 2021, but there are significant questions now about the program's costs and its timetable. In January, NASA announced its new target for a manned landing, late 2026, a year later than planned. But as we discovered, even that may be unrealistic.
And liftoff of Artemis 1.
When Artemis 1 soared into space in November of 2022, it was the beginning of a nearly flawless mission. In its first test flight, NASA's new Space Launch System rocket sent an empty Orion crew capsule on a 1.4 million-mile flyby of the moon before a picture-perfect return to Earth.
Splashdown.
The next flight, Artemis 2, meant to carry 4 astronauts on a lunar flyby, was supposed to launch this year. And then, a year later, Artemis 3 would land the first woman and first person of color on the moon. It's not working out quite that way.
I think it is safe to say, without significant reductions in costs, better cost controls, better planning, this Artemis program on its current trajectory is not sustainable.
George Scott is NASA's acting inspector general. Don't be misled by the acting. He's been a top agency watchdog for more than 5 years. While NASA's engineers have their heads in the stars, it's his job to bring them back to Earth, particularly when it comes to costs.
Right now, we're estimating that per launch, the Artemis campaign will cost $4.2 billion per launch.
Per launch?
Per launch. That's an incredible amount of money per launch. A lot of that hardware is just going to end up in the ocean, never to be used again.
The Inspector General for NASA says that the costs for the Artemis program are simply unsustainable. Is he wrong?
We didn't necessarily agree with their conclusions. We feel like we've taken an affordable path to do these missions.
Jim Free is NASA's associate administrator and directly in charge of Artemis. We met him at historic Launch Pad 39B, from which both Apollo and Artemis rockets have flown.
We believe that the rocket we have is best matched for the mission, and frankly, the only one in the world that can take crews to the moon.
Confirmation that the solid rocket boosters have separated.
But as George Scott said, most components of that SLS rocket end up in the ocean. They're not reusable. And with the goal of building an outpost on the moon, Artemis will need a lot of those $4.2 billion rockets. It's going to take launch after launch after launch to get all that stuff up there.
Yes. So the number of launches is daunting, but it's hard to get people to the moon.
You got something? Magnificent sight out here.
When America sent Neil Armstrong and 11 more astronauts to the moon a half-century ago,
that's beautiful.
They got to the lunar surface aboard landers.
We leave as we came, and God willing, as we shall return.
Owned and operated by NASA. You're taking a different approach this time than with Apollo. What's the difference this time?
The difference is we're buying it as a service. We're paying someone to take our crews down and take them up.
It's been an incredible year.
That someone is Elon Musk. In 2021, NASA signed a nearly $3 billion contract with his SpaceX to use its new Starship mega rocket as the lunar lander for the first Artemis astronauts.
It is by far the biggest flying object ever made.
SpaceX is preparing for its third Starship launch atop its enormous Super Heavy booster. The first 2 launches both ended in roughly the same way.
As you can see, the Super Heavy booster has just experienced a rapid unscheduled disassembly.
Rapid unscheduled disassembly is SpaceX speak for our Starship rocket just blew up again. And now you've seen some of the perils of relying on SpaceX.
We've seen some of the challenges they've had on Starship. We need them to launch several times to give us the confidence that we can put our crews on there.
But right now, as we sit here today, you have no way of getting the astronauts to the surface of the moon because of these problems that SpaceX has faced.
Because they haven't hit the technical milestones.
SpaceX's stated plan is to first put its Starship lander into low Earth orbit, then launch 10 more Starship tankers to pump rocket fuel into the lander in space.
Make sci-fi real.
Before sending it onward to meet astronauts in lunar orbit. And this has never been done before.
There's been small-scale transfers in orbit, but not of this magnitude.
It just sounds incredibly complicated.
It is complicated. There's no doubt about that. You just launch 10 times kind of on a whim.
If it's never been done before, chances are it's going to take longer than you think to do it, and to do it successfully and prove that technology before we trust putting humans on it. There's a long way to go.
NASA's contract with SpaceX requires the company to make an unmanned lunar landing with Starship before trying one with astronauts on board. But NASA still says the manned mission can happen in 2.5 years. And that just seems like the time frame we're talking about, the end of 2026, seems ambitious, to say the least.
What we're doing is ambitious, but it's a great goal to have.
Is that goal realistic?
I believe it is. I believe it is.
Jim Free's optimism is based on SpaceX's track record with its smaller Falcon rocket. Wow. Once it got the Falcon up and running, it demonstrated it can launch a lot, 96 times last year alone, with both commercial and government payloads. But so far, Starship has yet to reach orbit even once.
Does that concern you, that that's going to keep pushing that timeline back further?
Of course, it absolutely concerns me because we need them to launch multiple times.
SpaceX ignored our multiple requests for an interview or comment. But in an interview with the Daily Wire in January, Elon Musk said this.
We're hoping to have the first humans on the moon in less than 5 years.
My view of that is we have a contract with SpaceX that says they're going to launch our crew in the end of 2026.
Why does it really matter when we get back to the moon? Here's why. China has said it plans to send its taikonauts to the moon by the end of the decade, and NASA Administrator Bill Nelson has publicly expressed concern.
Naturally, I don't want China to get to the South Pole first with humans and then say, this is ours, stay out.
To ensure that the U.S. will plant its flag first, NASA signed a new $3 billion contract last year with Blue Origin, the space company owned by billionaire Jeff Bezos, to build another lunar lander. And Jim Free is crystal clear that he sees it as an option if SpaceX Starships keep blowing up.
So if we have a problem with one, we'll have another one to rely on. You know, if we have a dependency on a particular aspect in SpaceX or Blue Origin and it doesn't work out, then we have another lander that can take our crews.
In this battle of the stargazing billionaires, Bezos's Blue Origin has far fewer launches than Musk's SpaceX and has been far quieter about its ambitions until now.
So what we're looking to do is not only get to the moon and back, but make it reliable and repeatable and low cost.
John Coulouris's title at Blue Origin is Senior Vice President of Lunar Permanence, and it says a lot about the company's ambition.
The landers that Blue Origin's going to be building are reusable. We'll launch them to lunar orbit, and we'll leave them there. And we'll refuel them in orbit so that multiple astronauts can use the same vehicle back and forth.
Our cameras were among the first to be allowed inside Blue Origin's huge complex in Florida, just next to Kennedy Space Center.
So this is where the future is being built.
That's right. This is the main factory floor for the New Glenn rocket.
New Glenn is Blue Origin's first heavy-lift rocket. Its maiden launch will be sometime this year.
So you can see over here we have 3 different second stages already in build here.
The first New Glenn is already out at Blue Origin's launch complex. It's designed to carry all sorts of payloads, including the lunar lander being built for NASA.
So this is the Mark I lander. We call this our small lander.
This is the small one?
Yes.
It's actually a mock-up of their cargo lander in Blue Origin's Florida lobby. John Coulouris used to work at SpaceX, and he came over to Blue to help speed things up.
Is there a bit of a space race between you and SpaceX?
So the country needs competition. We need options. Competition brings innovation.
But you haven't had anything close to the accomplishments that SpaceX has had at this point, have you?
SpaceX has done some amazing things, and they've changed the narrative for access to space, and Blue Origin's looking to do the same. This lander, we're expecting to land on the moon between 12 and 16 months from today.
12 and 16 months from today.
Yes. And I understand I'm saying that publicly, but that's what our team is aiming towards.
But that's for the cargo lander. What about humans?
For humans, we're working with NASA on the Artemis 5 mission. That's planned for 2029.
That's not so different from Elon Musk's forecast of when SpaceX can land humans back on the moon, even if it doesn't match NASA's. Like the Starship,
Blue Origin's lander will require in-space refueling, but Coloris insists that it and their rocket will help NASA trim costs.
Our New Glenn vehicle will be a reusable vehicle from its first mission. That lander for the astronauts is a reusable lander. So now you're not just taking the equipment and throwing it away. You're reusing it for the next mission.
You do it again and again and again. Is that where the cost savings comes in?
Exactly. We are now building with NASA the infrastructure to ensure lunar permanency.
You have said that the Artemis program is the beginning, not the end. Tell me, what is the future you see?
I see us landing on Mars. Absolutely see us landing on Mars. But we have to work through the moon to get to Mars.
These are magnificent goals, going back to the moon, going to Mars. Do we have the ability to do what we're dreaming of doing?
This is NASA, right? This agency is destined to continue to do great things. There's no question about that. What we're telling the agency is just be more realistic. There's nothing wrong with being optimistic. In fact, it's required, right? In this business, optimism is required. The question is, though, can you also be more realistic?
For a long time, astronomers saw the asteroids and comets that come close to Earth as useless debris, space rocks that blocked our view of distant galaxies. Not anymore. They're now viewed as scientifically important and potentially very dangerous if they were to collide with our planet. The odds of that happening on any given day are remote, but over millions of years, scientists believe there have been lots of impacts, and few doubt there are more to come. A former astronaut told us it's like a game of cosmic roulette, and one mankind cannot afford to lose. Concern over our ability to detect these objects that come near the Earth grew after an incident in Russia this February, when an asteroid crashed into the atmosphere with many times the energy of the bomb dropped on Hiroshima, narrowly missing a city of 1 million. This is video of that asteroid in Russia, barreling toward Earth at 40,000 miles an hour. It exploded into pieces 19 miles above and 25 miles south of the city of Chelyabinsk. People thought it had missed them entirely until minutes later when the shockwave arrived. Shattering glass, crushing doors, and knocking some people right off their feet. More than 1,000 were injured. How much warning did people in Chelyabinsk have?
None.
Paul Chotis is a scientist at NASA's Jet Propulsion Laboratory in Pasadena, California. He and his boss, Don Yeomans, have been trying to track near-Earth objects for decades.
We didn't see it coming. It was coming from the general direction of the sun, so it was in the daytime sky as it approached.
So how did you find out about it?
Twitter and YouTube, when we first saw the images.
So the first people at NASA heard about it was Twitter?
Exactly.
Chotis says an object this size hits Earth once every 100 years on average. Yet the same day, purely by chance, another asteroid twice as large came within 17,000 miles of Earth, passing between us and the satellites that are bringing you this broadcast. The only reason there was any advance warning was because an amateur astronomer in Spain, an oral surgeon by day, noticed it just before it moved out of view.
We know about some of the most distant galaxies in the known universe, and yet we don't really know everything that's right in our own backyard.
Wow. Amy Mainzer is a NASA scientist who focuses on detecting asteroids.
So we got to move the dome out of the way, and then we're going to start to follow the asteroid as it tracks across the sky.
This telescope at the Table Mountain Observatory in California is one of dozens all over the world that are used to track and study near-Earth objects. Mainzer told us they're often very hard to find.
Some of these asteroids are really, really dark, darker even than coal in some cases, kind of like the soot at the bottom of a barbecue grill.
So you're looking for something that's darker than coal against a black sky?
Exactly. And now you see the problem.
Another problem is that ground-based telescopes can't see objects coming from the direction of the sun because they're in the daytime sky, like the asteroid that hit Russia. Astronomers find asteroids by taking repeated pictures of the night sky and looking for things that change position. Professionals and amateurs all over the world work together, sharing information. Once Paul Chotis and his NASA colleagues have multiple sightings, they can predict an object's location as far as 100 years into the future.
This particular object has a very well-known orbit because
The asteroid Amy Mainzer was observing the night we visited didn't look like much on her screen. That little thing.
Yep, that's it.
But it's nearly half a mile wide and capable of destroying an entire continent. So that's a huge asteroid.
Yeah, it's a huge asteroid. If something this size hit the Earth, it would be devastating. It would be very bad.
Asteroids are composed mostly of rock, comets, ice, and dust. They come in all shapes and sizes. Some look like small planets, others giant dog bones. For a long time, nobody thought they were worth tracking at all.
It wasn't thought that they really did hit the Earth. Astronomers debated for a long time about the nature of the craters on the Moon.
They thought the craters on the moon were volcanic.
Possibly, yeah. And it's only been fairly recently, within the last 50 years or so, that the field has really recognized that, yeah, impacts actually do happen. And not only do they happen on geological timescales, millions and billions of years, but on human timescales in some cases.
The last major asteroid to collide with Earth hit in 1908 in the Tunguska region of Siberia. It's believed to have been 40 yards wide and to have exploded in the air like a nuclear bomb, leveling 80 million trees in an area the size of metropolitan Washington. This crater in northern Arizona was created 50,000 years ago. It's one of more than 180 impact craters geologists have found so far. They think there are many more, hidden by water and vegetation, more even than on the moon, because the Earth's gravity is greater. The most famous impact of all is the one that may have wiped out the dinosaurs more than 65 million years ago. The theory is that an enormous asteroid or comet collided so violently with Earth, it created a cloud of debris that blocked out the sun, killing off 75% of all species, leaving behind a crater in Mexico more than 100 miles wide.
These are objects that were once in space, pieces of asteroids.
Yeomans and Chodas showed us some of the remarkable things that have fallen from the sky. This is a piece of Mars.
You have it in your hand. It wandered around the inner solar system for a few million years, and a 40-pound stone came down in Africa about 10 feet from a farmer in October of 1962.
It's amazing to think this is from Mars. It's
yeah, I know.
They played a trick on me as well.
Say, would you hand that one to me? That big one? Yeah. Come on.
Oh my God. This one was iron nickel and heavy as an anvil. Not all asteroids are made of such dense stuff, but many contain high concentrations of valuable minerals like platinum that might someday be mined in space.
We'll start by sending astronauts to an asteroid for the first time in history.
President Obama's proposed budget for next year includes a plan to capture a tiny asteroid so that astronauts could rendezvous with it by 2025. The idea is to perfect techniques needed to explore deep space and perhaps find a way to exploit the water resources that many comets and asteroids have.
You could extract water from them. You can break the water down into hydrogen and oxygen, which is the most efficient form of rocket fuel. So asteroids may serve as the fueling stations and watering holes for future planetary exploration.
But as the scriptwriters of the Hollywood blockbuster Armageddon vividly imagined, asteroids have the potential to harm mankind as well. For better or worse, this is what many of us know about near-Earth objects. That if Bruce Willis hadn't nuked one, it would have destroyed the world. You see these movies with Bruce Willis where an asteroid is coming and is going to destroy the world. Is that likely?
No, no. We found 95% of the large ones, and none of them represent a threat in the next 100 years or so.
What about the other 5%?
We're still looking.
He's talking about objects over half a mile wide that are big enough to cause global destruction. The problem is there are lots of smaller objects, over 40 yards in diameter, that are unaccounted for and potentially very dangerous.
If you look at the light green dot, that's the orbit of the Earth.
Ed Liu is a former astronaut who spent 6 months on the International Space Station. He showed us a computer-generated representation of our solar system. That's the sun in the center, and those green dots are 10,000 near-Earth objects astronomers have found so far.
So these green dots are the asteroids that could hit the Earth.
This is about the 10,000 known asteroids.
Yes, these are the 10,000 known asteroids. Here's the problem. There's about a factor of 100 more. The real solar system looks like this. And we know this because we've only been able to observe a small fraction of the sky, and we know that there's about 100 times more asteroids than we've found.
This is all the asteroids that are...
There are about 1 million asteroids large enough to destroy a city out there.
And right now we only know of what percent of those asteroids?
About 0.5%.
Does it worry you that you only know 1% of these asteroids that are big enough to destroy a city?
Well, most of those are really small, and the odds are that many of these would hit in a remote area or could hit in an ocean. So that is why the larger ones are those that we were paying attention to first. Now, the next size range is the one to concentrate on, those that can cause, continent-wide extinction or destruction.
Yeah, that would be pretty good to prevent that continent-wide destruction.
Those are the next ones. We'll continue to find those, and we work our way down to the small ones.
But right now, an object that could wipe out the eastern seaboard or New York City could be a day away, and there's a very good chance we wouldn't know about it.
Well, we're working to make sure that we will know about it.
But right now, we wouldn't know about it.
It's possible. Yes.
The Committee on Science, Space, and Technology will come to order.
NASA Administrator Charles Bolden faced similar questions from Congress after the near miss in Russia earlier this year.
What would we do if you detected even a small one, like the one that detonated in Russia, headed for New York City in 3 weeks? What would we do?
If it's coming in 3 weeks, pray.
Is there anything you can do to deflect an asteroid that's going to hit besides evacuating a city?
If you find it 10 or 20 or 30 years in advance, then yes, you could actually send a spacecraft up, run into it, slow it down 1 millimeter or 2 per second so that in 10 or 20 years when it was predicted to hit the Earth, it wouldn't.
Just slam a spacecraft into it.
Just slam into it.
In 2005, NASA did just that as an experiment, firing a small unmanned spacecraft into a comet called Tempel 1. But you can't deflect what you don't detect, which is why former astronaut Ed Lu has taken on a new mission.
Here's the telescope that we're building.
He's now chairman of the B612 Foundation, which has designed a space-based telescope to speed up the discovery of near-Earth objects. NASA's Amy Mainzer has been developing one too. Both telescopes would be able to find asteroids by using infrared sensors that detect heat rather than light. But a telescope like this would cost roughly $500 million, and so far neither the United States nor any other government has committed significant funds. So the B612 Foundation is trying to raise the money privately by reaching out to individual donors.
I don't think there's any other global catastrophe, global scale catastrophe that we can prevent. This is the only one that I know of. We can solve this particular issue for the cost of building a freeway overpass. I mean, that's literally what it is.
But nobody has been killed by an asteroid.
Yeah. And what I'm saying is that you can't wait to that point afterwards when you say we should have done it. You have to think of this as cosmic roulette, right? The phrase that they have in Vegas is that the house always wins. And the sort of secret to all this is that we're not the house. At some point, the solar system's going to get you.
They're very low probability events, but very high consequence events.
The problem, it seems like, is you're asking people to care about something which may not affect their lives, may not even affect their children's lives.
That's true. It's a tough concept to get across because, as you say, it's something that may not happen for another 100 years, 200 years. It may happen tomorrow morning.
Earlier this summer, the Director of National Intelligence and Secretary of Defense released a highly anticipated, unclassified report about something the Pentagon calls unidentified aerial phenomena, or UAP, more commonly known as UFOs. The government's grudging acknowledgement of 144 mysterious sightings documented by our military comes after decades of public denial. But as we first reported in May, whatever is trespassing in our skies and seas poses a serious safety risk to our servicemen and women, as well as our national security. So what you're telling me is that UFOs, unidentified flying objects, are real?
Bill, I think we're beyond that already. The government has already stated for the record that they're real. I'm not telling you that. The United States government is telling you that.
Luis Elizondo spent 20 years running military intelligence operations worldwide in Afghanistan, the Middle East, and Guantanamo. He hadn't given UFOs a second thought until 2008. That's when he was asked to join something at the Pentagon called the Advanced Aerospace Threat Identification Program, or ATIP.
The mission of ATIP was quite simple. It was to collect and analyze information involving anomalous aerial vehicles. What I guess in the vernacular you call them UFOs. We call them UAPs.
You know how this sounds. It sounds nutty, wacky.
Look, Bill, I'm not telling you that it doesn't sound wacky. What I'm telling you, it's real. The question is, what is it? What are its intentions? What are its capabilities?
Buried away in the Pentagon, ATIP was part of a $22 million program sponsored by then Senate Majority Leader Harry Reid to investigate UFOs. When Elizondo took over in 2010, he focused on the national security implications of unidentified aerial phenomena documented by U.S. service members.
Imagine a technology that can do 600 to 700 G-forces, that can fly at 13,000 miles an hour, that it can evade radar, and that can fly through air and water and possibly space. And, oh, by the way, has no obvious signs of propulsion, no wings, no control surfaces, and yet still can defy the natural effects of Earth's gravity. That's precisely what we're seeing.
Elizondo tells us ATIP was a loose-knit mix of scientists, electro-optical engineers, avionics, and intelligence experts, often working part-time. They combed through data and records and analyzed videos like this. A Navy aircrew struggles to lock on to a fast-moving object off the U.S. Atlantic coast in 2015. Recently released images may not convince UFO skeptics, but the Pentagon admits it doesn't know what in the world this is. Or this. Or this.
So what do you say to the skeptics? It's refracted light, weather balloons, a rocket being launched, Venus.
In some cases, there are simple explanations for what people are witnessing, but there are some that are not. We're not just simply jumping to a conclusion that's saying, oh, that's a UAP out there. We're going through our due diligence. Is it some sort of new type of cruise missile technology that China has developed? Is it some sort of high-altitude balloon that's conducting reconnaissance? Ultimately, when you have exhausted all those what-ifs and you're still left with the fact that this is in our airspace and it's real, that's when it becomes compelling and that's when it becomes problematic.
Former Navy pilot Lieutenant Ryan Graves calls whatever is out there a security risk. He told us his F-18 squadron began seeing UAPs hovering over restricted airspace southeast of Virginia Beach in 2014 when they updated their jet's radar, making it possible to zero in with infrared targeting cameras.
So you're seeing it both with the radar and with the infrared, and that tells you that there is something out there.
Pretty hard to spoof that.
These photographs were taken in 2019 in the same area. The Pentagon confirms these are images of objects it can't identify. Lieutenant Graves told us pilots training off the Atlantic coast see things like that all the time.
Every day. Every day for at least a couple of years.
Wait a minute, every day for a couple of years?
Mm-hmm. I don't see an exhaust plume.
Including this one, off the coast of Jacksonville, Florida in 2015, captured on a targeting camera by members of Graves' squadron.
Look at that thing. It's rotating. Oh my gosh. They're all going against the wind. The wind's 120 knots to the west. Look at that thing, dude.
You can sort of hear the surprise in their voices.
You certainly can. They seem to have broke character a bit. And we're just kind of amazed at what they were seeing.
What do you think when you see something like this?
This is a difficult one to explain. You have rotation, you have high altitudes, you have propulsion, right? I don't know. I don't know what it is, frankly.
He told us pilots speculate they are one of three things: secret U.S. technology, an adversary spy vehicle, or something otherworldly.
I would say, the highest probability is it's a threat observation program.
Could it be Russian or Chinese technology?
I don't see why not.
Are you alarmed?
I am worried, frankly. You know, if these were tactical jets from another country that were hanging out up there, it would be a massive issue. But because it looks slightly different, we're not willing to actually look at the problem in the face. We're happy to just ignore the fact that these are out there watching us every day.
The government has ignored it, at least publicly, since closing its Project Blue Book investigation in 1969. But that began to change after an incident off Southern California in 2004, which was documented by radar, by camera, and 4 naval aviators. We spoke to 2 of them. David Fravor, a graduate of the Top Gun Naval Flight School and commander of the F-18 squadron on the USS Nimitz, and flying at his wing, Lieutenant Alex Dietrich, who has never spoken publicly about the encounter.
I never wanted to be on national TV, no offense.
So why are you doing this?
Because I was in a government aircraft, because I was on the clock. And so I feel a responsibility to share what I can, and it is unclassified.
It was November 2004, and the USS Nimitz Carrier Strike Group was training about 100 miles southwest of San Diego. For a week, the advanced new radar on a nearby ship, the USS Princeton, had detected what operators called multiple anomalous aerial vehicles over the horizon, descending 80,000 feet in less than a second. On November 14th, Fravor and Dietrich, each with a weapons system officer in the back seat, were diverted to investigate. They found an area of roiling whitewater the size of a 737 in an otherwise calm blue sea.
So as we're looking at this, her backseater says, "Hey, Skipper, do you?" And about that got out, I said, "Dude, do you see that thing down there?" And we saw this little white tic-tac looking object, and it's just kind of moving above the whitewater area.
As Dietrich circled above, Fravor went in for a closer look.
So sort of spiraling down?
Yep. The tic-tac's still pointing north-south. It goes and just turns abruptly and starts mirroring me. So as I'm coming down, it starts coming up.
So it's mimicking your moves.
Yeah, it was aware we were there.
He said it was about the size of his F-18, with no markings, no wings, no exhaust plumes.
I'll see how close I can get. So I go like this, and it's climbing still. And when it gets right in front of me, it just disappears.
Disappears?
Disappears. Like gone.
It had sped off. What are you thinking?
So your mind tries to make sense of it. I'm going to categorize this as maybe a helicopter or maybe a drone. And when it disappeared, I mean, it was just...
Did your backseaters see this too?
Yeah.
Oh, yeah. There was 4 of us in the airplanes literally watching this thing for roughly about 5 minutes.
Seconds later, the Princeton reacquired the target, 60 miles away. Another crew managed to briefly lock onto it with a targeting camera before it zipped off again.
You know, I think that over beers, we've sort of said, hey, man, if I saw this solo, I don't know that I would have come back and said anything because it sounds so crazy when I say it.
You understand that reaction?
I do. I've had some people tell me, you know, when you say that, you can sound crazy. And I'll be honest, I'm not a UFO guy.
But from what I hear you guys saying, there's something.
Yes.
Oh, there's definitely something that, I don't know who's building it, who's got the technology, who's got the brains, but there's something out there that was better than our airplane.
The aircrew filed reports. Then, like the mysterious flying object, the Nimitz encounter disappeared. Nothing was said or done officially for 5 years, until Lou Elizondo came across the story and investigated.
We spend millions of dollars in training these pilots, and they are seeing something that they can't explain. Furthermore, that information is being backed up on electro-optical data, like gun camera footage, and by radar data. Now, to me, that's compelling.
Inside the Pentagon, his findings were met with skepticism. ATIP's funding was eliminated in 2012, but Elizondo says he and a handful of others kept the mission alive, until finally, frustrated, he quit the Pentagon in 2017, but not before getting these 3 videos declassified. And then things took a stranger turn.
I tried to help my colleague Lou Elizondo elevate the issue in the department and actually get it to the Secretary of Defense.
Christopher Mellon served as Deputy Assistant Secretary of Defense for Intelligence for Presidents Clinton and George W. Bush and had access to top-secret government programs.
So it's not us. That's one thing we know.
We know that.
I could say that with a very high degree of confidence, in part because of the positions I held in the department, and I know the process.
Mellon says he grew concerned nothing was being done about UAPs, so he decided to do something. In 2017, as a private citizen, he surreptitiously acquired the 3 Navy videos Elizondo had declassified and leaked them to the New York Times.
It's bizarre and unfortunate that someone like myself has to do something like that to get a national security issue like this on the agenda.
He joined forces with now civilian Lou Elizondo, and they started to tell their story to anybody who would listen, to newspapers, the History Channel, to members of Congress.
We knew and understood that you had to go to the public, get the public interested, to get Congress interested, to then circle back to the Defense Department and get them to start taking a look at it.
And now it is. Last year, the Pentagon resurrected ATIP. It's now called the UAP Task Force. Service members now are encouraged to report strange encounters, and the Senate wants answers.
Anything that enters an airspace that's not supposed to be there is a threat.
After receiving classified briefings on UAPs, Senator Marco Rubio called for a detailed analysis. This past December, while he was still head of the Intelligence Committee, he asked the Director of National Intelligence and the Pentagon to present Congress an unclassified report by next month.
This is a bizarre issue. The Pentagon and other branches of the military have a long history of sort of dismissing this. What makes you think that this time is going to be different?
I mean, we're going to find out when we get that report. You know, there's a stigma on Capitol Hill. I mean, some of my colleagues are very interested in this topic and some kind of, giggle when you bring it up. But I don't think we can allow the stigma to keep us from having an answer to a very fundamental question.
What do you want us to do about this?
I want us to take it seriously and have a process to take it seriously. I want us to have a process to analyze the data every time it comes in, that there be a place where this is cataloged and constantly analyzed until we get some answers. Maybe it has a very simple answer. Maybe it doesn't.
A few weeks after our story aired, the Director of National Intelligence released an unclassified report saying UAP probably lack a single explanation, but that some, quote, appear to demonstrate advanced technology meriting further analysis.
Without most of us noticing, our everyday activities, everything from getting cash at an ATM to watching this program, depend on satellites in space. And for the U.S. military, it's not just everyday activities. The way it fights depends on space. Satellites are used to communicate with troops, gather intelligence, fly drones, and target weapons. But top military and intelligence leaders are now worried those satellites are vulnerable to attack. They say China in particular has been actively testing anti-satellite weapons that could, in effect, knock out America's eyes and ears. No one wants a war in space, but it's the job of a branch of the Air Force called Space Command to prepare for one. If you've never heard of Space Command, it's because most of what it does happens hundreds, even thousands of miles above the Earth or deep inside highly secure command centers. You may be as surprised as we were to find out how the high-stakes game for control of space is played. The research being done at the Starfire Optical Range in Albuquerque, New Mexico, was kept secret for many years. And for a good reason, which only becomes apparent at night. First, the roof of one building is open to the stars. Then the walls retract, and an object straight out of Star Wars appears, shooting a laser into the sky. The laser's beam helps a high-powered telescope focus in on objects in space, so the Air Force can get a better look at the satellites of potential adversaries like China whizzing by at 17,000 miles per hour. It's part of a complex and mostly secret battle for what the military considers the ultimate high ground.
There is no such thing as a day without space.
That's the mantra of General John Hyten, the head of Air Force Space Command.
Think of what life used to be like and all the things that we have today in warfare that wouldn't exist without space. Remotely piloted aircraft, all-weather precision-guided munitions didn't exist before space. Now we can attack any target on the planet, anytime, anywhere, in any weather.
What would the U.S. military do without space?
What happens is you go back to World War II. You go back to industrial age warfare.
And your job is to make sure there is no day without space.
Absolutely. And you should be thinking right from the beginning that this is a contested environment. And
Hyten drills into his troops that U.S. satellites are no longer safe from attack. 11 countries, including Iran and North Korea, now have the ability to launch objects into orbit. And Russia and China have been testing new anti-satellite technologies.
That's a competition that I wish wasn't occurring, but it is. And if we're threatened in space, we have the right of self-defense. And we'll make sure we can execute that right.
And use force if necessary.
That's why we have a military. You know, I'm not NASA.
Space Command has 38,000 airmen at 134 locations around the world.
Well, if you look at the
One of their most visible missions is to make sure U.S. satellites can always get into space, from launch pads like this one at Vandenberg Air Force Base in California.
This is where space begins. If you can't get the satellite into space, it's worthless. I'm a satellite guy, so I get very nervous around rockets because the most valuable thing on the rocket is the top, is the satellite. Because when you have 500,000 pounds of thrust, if anything goes wrong, it's an explosion, it's dangerous, and you lose the capabilities that's on the top.
T-minus 15 seconds, stand by for
The U.S. has more satellites in space than any other nation, over 500 and counting. More than 30 military and civilian launches will take place this year at Space Command bases in Florida and California.
0.
The Pentagon told us it spends $10 billion a year on space, but we found a White House report that estimates the real cost is much higher, $25 billion when you count spy satellites and other classified spending. That's more than NASA or any other space agency in the world. Some of those satellites provide the GPS signals that guide smart bombs now attacking ISIS targets in Iraq and Syria. But a lot of people don't realize those same GPS satellites provide the signals your smartphone uses to navigate. It's a service the Air Force provides free, not just here in the United States, but to the entire world.
This is a global utility, and there's a lot of people depending on this, and we understand that.
At a Boeing plant in Los Angeles, Colonel Bill Cooley showed us a GPS satellite that was being tested in a special chamber to make sure it was ready for launch.
When these things get on orbit, there's no depot. You can't drive it back into the maintenance shop. It's somewhat like trying to design an automobile that is going to run for 12 to 15 years, and you can't take it in the shop, you can't take it in for refueling, but it's got to run 24/7.
In orbit, the satellite will spread out its solar panels, point its odd-looking antennas toward the Earth, and broadcast its location along with a time signal accurate to nanoseconds. A GPS receiver needs signals from 4 of these satellites to figure out its location. Colonel Cooley told us it costs $250 million to design and build each one.
And to put it into space, how much does it cost?
Yeah, that's about the same.
So you're pushing $500 million to get that thing into space.
That's right.
The U.S. has 31 active GPS satellites in space right now, and a lot more than smart bombs and smartphones depend on them. Bank ATMs, cell phone towers, and power grids use their signals. Farmers use GPS to work their fields.
So at your active time, you're just going to go active.
The GPS satellite system the whole world relies on is operated out of this room at Schriever Air Force Base in Colorado by Lieutenant Colonel Todd Benson and his team.
Pre-pass SVN 34.
We were a little surprised by how many people it takes.
8 personnel.
8 people?
Yes, sir.
For the entire world?
Yes, sir.
Are these technological experts?
Yes, sir. But they're as young as 19 years old.
Isn't there a minimum age for driving satellites?
Not here.
Another thing that surprised us is there's no way to effectively armor an important satellite like this, or to conceal its location from attack.
So it can't hide in space?
That's true. And in fact, it tells you where it is.
This is a system the whole world depends on. Costs a small fortune to put it up there, and it's a sitting duck.
Well, this is one of the challenges that in Space Command that we are very aware of.
Today, can a U.S. military satellite maneuver itself out of the way of an upcoming anti-satellite weapon?
It depends on a huge number of variables.
So the answer is maybe.
The answer is maybe.
So you've got these satellites worth hundreds of millions of dollars, and they maybe could get out of harm's way?
Depends on the satellite, it depends on the mission, it depends on when it was built, depends on how old it is, it depends on when we know the threat is coming.
Knowing a threat is coming is no small task when the territory you're responsible for is 73 trillion cubic miles. Space Command maintains a global network of radars, telescopes, and satellite communications antennas like this one.
And you can see the magnetic lines just, they're looping all over.
All the information feeds into the Joint Space Operations Center, JSPOC for short, at Vandenberg Air Force Base.
This is the command center for space.
Yes, sir. 24/7, 365 days a year.
If a U.S. satellite were attacked, Lieutenant General Jay Raymond would use this phone to alert a chain of command leading to the White House.
Is an attack on an American satellite an act of war?
That's been a line of debate for as long as I've been in this business.
If there is an attempt to attack or interfere with the U.S. satellite, who makes the decision about what we do about it?
That'd be the President of the United States.
And it's not just an anti-satellite weapon they're worried about. There are other dangers, too.
Today, we track about 23,000 objects.
How many of them are actually functioning satellites?
Roughly 1,300 of those are active satellites. The rest are debris.
Junk?
Yes, sir, junk.
The movie Gravity dramatized the devastating effect man-made debris traveling at 17,000 miles per hour could have on the International Space Station. The JSPOC tracks dead satellites, old rocket boosters, even stray space gloves, and alerts satellite operators and astronauts if a collision is likely.
Last year, in 2014, the International Space Station was maneuvered 3 times to avoid colliding with a piece of debris.
A lot of the debris that's threatening the space station was created in 2007 when the Chinese tested a ground-based anti-satellite weapon. It crashed into one of their old weather satellites 530 miles above the Earth, shattering it into pieces.
This is the debris that resulted from the 2007 Chinese ASAT. So this is about 3,000 pieces of debris just from that one event.
That came just from that one collision?
Just from that one collision.
Debris apart, how important was that test in terms of revealing Chinese space capabilities?
It was a significant wake-up call to our entire military. Until that singular event, I don't think the broader military realized that that is something we're going to have to worry about.
Have they conducted any similar tests since?
They continue to conduct tests. The testing they're doing is to make sure that if they ever got into a conflict with us or any other spacefaring nation, they would have the ability to destroy satellites. And that is a bad thing for the United States, a bad thing for the planet.
A bad thing, no doubt. But is the U.S. doing it too? And did China recently raise the stakes, test firing a weapon deeper into space than ever before and threatening some of this country's most valuable satellites? That part of our story when we come back. Tonight, we've been giving you a rare look at how a branch of the U.S. Air Force called Space Command is preparing for a battle most of us have never thought about, one high above the Earth, defending the satellites upon which our daily life and national security have come to depend. Few of those satellites are more important to the U.S. military than the ones that provide early warning of a long-range nuclear missile attack. Even at the height of the Cold War, those satellites stationed deep in space, some 20,000 miles above the Earth, were considered safe from attack. But deep space is no longer the sanctuary it once was. A former Space Command officer told us that 2 years ago, the Chinese tested an anti-satellite weapon that went higher than any previously reported and came too close for comfort to the area where those missile warning satellites are located.
If those satellites are now at risk, that is something that, from the U.S. military's point of view, is new. Because it's always believed those satellites, there wasn't really a significant threat to those capabilities.
Brian Whedon served as an officer in Air Force Space Command until 2007. He's now technical advisor to the Secure World Foundation, which promotes the peaceful use of space.
The topic for today's discussion
Whedon says the Chinese have test-fired as many as 6 ground-based anti-satellite weapons. Only one in 2007 actually hit a satellite and created debris, but one of the others soared to new heights.
There was one test in May of 2013 that may have gone as high as 30,000 kilometers. And that's one that I think really is kind of causing quite a bit of concern on the U.S. side.
To understand just how far that is, the International Space Station orbits at about 200 miles above the Earth, and those GPS satellites we showed you orbit at 12,000 miles. The 2013 test launch Whedon's talking about is believed to have gone up to 18,600 miles, just shy of what's known as geosynchronous or geostationary orbit. And that's where the U.S. military has stationed some of its most valuable missile warning sensors and top-secret communications devices that serve as its eyes and ears in time of war.
I think what keeps a lot of American military planners up at night is if China has anti-satellite capabilities, when do they use those in a conflict? Do they use them at the start to try and blind the U.S.?
Those sound like the crown jewels of American satellites up there in geosynchronous orbit.
Absolutely. Those satellites were developed in an environment where the U.S. assumed there would not be reason to attack them. So you end up with a small number of very expensive satellites that have a lot of capability packed onto each one. And result is juicy targets.
A spokesman for China's foreign ministry admitted testing an anti-satellite weapon in 2007. But China has denied conducting subsequent tests and told us it is committed to the peaceful use of outer space. It said the 2013 launch into deep space was simply a science experiment. But using skills he honed as an officer in Space Command, Brian Whedon analyzed commercial satellite photos and other publicly available data about the launch. He concluded that science experiment was probably fired into space by a military missile launcher like this.
This building was built in the...
General John Hyten, the head of Air Force Space Command, has seen the classified intelligence about that launch.
These follow-on Chinese tests, how high up do they go?
Pretty high.
Well, how high is that?
I won't characterize what the Chinese capabilities are. I just will tell you that we know what they are.
Well, I've read reports by a congressional commission which said that in the next 5 to 10 years, China likely will be able to hold at risk U.S. national security satellites in every orbital regime. Do you agree with this statement by the Commission?
I think they'll be able to threaten every orbital regime that we operate in. Now, we have to figure out how to defend those satellites, and we're going to.
Space Command is making its new satellites more maneuverable to evade attack, and also more resistant to jamming. It's building a new radar system that will enable the Space Operations Center to track objects in space as small as a softball. And it's deployed 2 highly maneuverable surveillance satellites to keep watch on what other countries are doing high up in geostationary orbit.
Satellites watching other satellites.
Satellites watching other satellites.
And how do they improve your knowledge?
Because they're up close.
Normally, the capabilities of spy satellites are kept top secret. But Space Command put out this fact sheet about its new assets in geosynchronous orbit.
We want people to understand that we're watching. There will be no surprises in geo, and we want everybody in the world to know that there will be no surprises in that orbit. It's way too valuable for us to just be surprised.
Deterrence in the nuclear world was built on weapons.
Right, and deterrence in the space world has got to be built on a little bit different construct. It's the ability to convince an adversary that if they attack us, they will fail.
Air Force Secretary Deborah Lee James told us the Pentagon plans to spend an extra $5 billion over the next 5 years to protect its satellites.
What do you consider to be the greatest single threat to U.S. satellites?
An anti-satellite weapon would certainly be a great threat. A laser would be a threat. Jamming capabilities are also a threat.
Do China and Russia have lasers that could blind American satellites?
They are testing and investing, and that is worrisome to the United States.
All right, good morning, Bravo crew. We're going to start it off with intel.
Testing and investing in sometimes mysterious ways.
Hey, Russia is going to be launching a Soyuz 2-.
Last year, airmen at the Joint Space Operations Center monitored the seemingly routine launch of 3 Russian communications satellites. Lieutenant General Jay Raymond and his team spotted what they assumed was just an ordinary piece of debris from the launch.
About a week later, a young Air Force captain detected that debris started to move.
Move as in maneuver, right up close to the body of the rocket that had launched it into space.
So what is that object that keeps maneuvering in space?
David, I'm not going to speculate, but I can tell you what it isn't. It's not a piece of debris.
That type of maneuver is what's called a rendezvous and proximity operation. And it's actually something that the U.S. has been working on for the last several years, if not longer.
Satellites that can rendezvous with other satellites may someday be used to refuel or make repairs, but they're potential weapons as well.
If you can get close enough to inspect or service another satellite, is that close enough to disable it?
Absolutely. And there's a wide range of ways you could do that.
Such as?
Breaking off a solar panel. Or even some have theorized, spray painting over optics so that the satellite can't see anything.
So if you thought space was a peaceful haven, think again. This is a new kind of space race, a cosmic game of hide and seek. And the same technology that enables this telescope to see more clearly into space could potentially be used to help a laser weapon focus more powerfully on a target. The Bush administration wanted to develop such a weapon here in 2006, but ran into resistance from Congress.
Is any work being done on lasers that could be used to blind satellites?
There's no such work at this time.
Does the U.S. have any weapons in space?
No, we do not.
I'm thinking of satellites that maneuver next to another satellite and then take some action to disable it without blowing it up.
We do have satellites that maneuver, that look at things in space, but not what you just described.
Do you think the Chinese believe that?
I don't know what they believe.
When the Chinese look at America's space operations, they see a program that by most estimates spends 10 times more than they do and has tested anti-satellite weapons of its own. Space Command told us an American F-15 fired a missile into space 5 times in the 1980s, and one of those times destroyed a U.S. satellite, creating debris that remained in space for decades. One of the officers involved in that test was General Hyten.
I think it was a surprise to most people on that program how much debris we created.
So where do we get off lecturing the Chinese about testing anti-satellite weapons if we were the first and if we created debris?
Well, because we learned our lesson and told the world, and the Congress said you will not test that weapon anymore.
But when a U.S. intelligence satellite containing hazardous fuel malfunctioned in 2008, the Navy's Aegis defense system, designed to knock out incoming missiles, was used to shoot it down.
Chinese must think we've got an anti-satellite capability as well.
I think they certainly have come to that conclusion, or not. If the U.S. doesn't have a capability, they certainly could field one very quickly.
What you just described is the formula for an arms race. They see a capability, we have a capability, they react to that capability, they react, we react, and there you go.
I think it certainly could turn out that way.
One of the big dangers is that a problem in space could inflame a conflict here on Earth. For instance, if a nation suddenly lost its early warning satellites in the middle of a crisis, it might assume it was the beginning of an attack.
Now, in reality, it might have been a simple manufacturing failure, it might have been a piece of space debris. But in the moment of crisis, I think that's the sort of situation that could escalate something that might otherwise have stayed partly contained.
General Hyten told us Space Command is currently only developing weapons that do not create debris, like this mobile jammer, which can be used to incapacitate satellites.
We have a capability called a counter-communication system that is built to deny an adversary the use of space communications. All I can say is it's a capability that exists on the ground, and it does not create debris in any way.
The only two things you've told me about the U.S. ability to fight in space are the ability to maneuver your satellites and to jam other satellites. Is that it?
That's not it, but that's all I can tell you.
One secret project is hiding in plain sight. It's the X-37B spaceplane, a small, remotely piloted vehicle that can fly in space for 20 months at a time.
This is a model of the space.
A model of it hangs in Huyton's headquarters in Colorado.
So here's your chance to end all the speculation about what the spaceplane is really for.
It's really for cool things.
For instance?
For instance, it goes up to space, but unlike other satellites, it actually comes back. Anything that we put in the payload bay that we take up to space, we can now bring back, and we can learn from that.
Can you tell me whether or not someday the spaceplane is going to become a weapon system?
The intent is, I cannot answer that question.
But if you're determined not to create any more debris in space, why can't you say that this might not become a weapon system?
I'm not going to say what it's going to become, because we're experimenting.
Huyton told us there are bound to be conflicts in space. The important thing is to avoid a shooting war that could create so much debris it might become impossible to put satellites or astronauts into orbit.
The Chinese, of course, look at everything you're doing.
I'm sure they're looking at this.
And they say you're developing the capability to threaten them, and that all those satellites are a direct threat to their national security. So why wouldn't they create a capability to take out those satellites?
You know, the Chinese are also building a very robust exploration program to go to the moon, to explore the stars. They could destroy their entire program by going down the way they are.
There's not a shooting war going on out there, but it sure does seem like there is a very high-stakes contest going on in space.
It is high stakes.
High stakes with very few rules. A 1967 UN treaty calls for the peaceful use of space. That sounds nice, but leaves a lot of room for countries to do what they want.
Right now, is there any code of conduct for space operations?
There is not an agreed-upon code of conduct.
So it's every country for himself?
Pretty much.
It's been a year since the tiny helicopter Ingenuity and the one-ton rover Perseverance left planet Earth, and they've come a very long way since then. In February, they landed in a hazardous and previously unexplored part of Mars called the Jezero Crater, where Perseverance will be looking for signs of ancient life. In April, Ingenuity disconnected from Perseverance's belly and made history, performing the first flights ever in the atmosphere of another planet. It's hard to imagine, but worth remembering as you watch this story we first broadcast in May, that this all happened millions of miles away in outer space. On April 6th, in this desolate Martian crater, 170 million miles from Earth, Perseverance posed for a selfie with Ingenuity, the little helicopter it had just dropped off. 2 weeks later, the rover's cameras recorded Ingenuity's historic first flight, hovering 10 feet off the ground for 30 seconds. It may not look like much, but for those who'd worked so long to make it happen, it was a reason to rejoice. Project manager Mimi Ong led the team at NASA's Jet Propulsion Laboratory in California that's been working on Ingenuity for 6 years.
How hard is it to fly a helicopter on Mars?
Very, very, very hard. We really truly started with the question of, is it possible?
A lot of people thought it could not be done.
Because it's really counterintuitive. I mean, you need atmosphere. For the blades to push, atmosphere to get lift.
The atmosphere on Mars is completely different than the world.
The atmosphere at Mars is so thin. I mean, the room we're in, right? It's compared to that, it was 1% of the atmospheric density over there. So the question of really, can you generate enough lift, to really to lift up anything? That was the fundamental question.
In subsequent flights, Ingenuity has gone higher and farther, traveling more than a mile in all over the surface of Mars. It is a triumph not only for NASA, but for its partners in the private sector, who help make various parts of the helicopter.
Don't let it go. Don't freak out.
Matt Keenan has a history of making unusual things that can fly. He's an engineer at a company called AeroVironment, which produces drones for military and civilian use.
I mean, that's incredible.
10 years ago, for a military research project, Keenan and his team created this robotic hummingbird, which has a tiny camera on board.
Whoa! There it is. Oh my God, that's amazing.
Keenan and engineer Ben Peipenberg led the AeroVironment team that created Ingenuity's rotors, motors, and landing gear.
Why was this so challenging?
Because it has to be a spacecraft as well as an aircraft. And flying it as an aircraft on Mars is pretty challenging because of the density of the air that's similar to about Earth at 100,000 feet.
How do you go about it?
Well, so building everything extremely lightweight is really, really critical.
The helicopter's blades, for example, are made of a styrofoam-like material coated with carbon fiber. They're stiff and strong.
Get a sense of how lightweight and stiff that is.
I mean, it's nothing.
Yeah, it weighs nothing.
But incredibly light.
Here we go, taking off.
This is the first time they've shown an outsider this version of Ingenuity, which they plan to use for education and research. They call it Terry.
A lift off.
Here on Earth, Terry's blades are spinning at about 400 revolutions per minute. On Mars, in the thin atmosphere, they'd have to spin 6 times faster to generate the same lift.
And then land.
Ingenuity costs $85 million to build and operate. Terry, a lot less, but it's still nerve-wracking to be handed its controls.
All right, go ahead. You've got it. Slide it right. You can push it all the way to the right if you want. Slide left. Wow. I'll bring it up a little bit. Now stop.
The joysticks we use to fly Terry are of no use on Mars. Radio signals take too long to get there.
All right, let me take over now. I've switched you out, and we'll go back to the...
Even someone as good at flying drones and hummingbirds as Matt Keenan couldn't fly a helicopter on Mars. Here's what happened in 2014 in a test chamber that replicated the atmosphere on Mars when Keenan tried to use a joystick to fly an early version of Ingenuity.
Surprise!
Wow. All right. So much for that vehicle. So this very quick demonstration is to show you a human being can't respond quickly enough to control it.
Exactly.
So engineers at the Jet Propulsion Laboratory equipped Ingenuity with a computerized system that allows it to stabilize itself and navigate on its own. In 2016, the new system aced the chamber test.
The blades are being commanded, 400 or 500 times per second.
They proved it could fly, but Ingenuity still had to weigh under 4 pounds and fit in the belly of Perseverance.
5, 4, engine ignition, 2, 1.
And it had to be tough enough to survive the journey to Mars.
And liftoff.
On July 30th, 2020, Perseverance and Ingenuity took off from Cape Canaveral. Nearly 7 months later, as this simulation shows, the spacecraft's heat shield hit the Martian atmosphere, going 12,000 miles per hour.
Perseverance ready to execute entry, descent, and landing on her own.
As he sat in the control room, Al Chen, the leader of the landing team, had absolutely no control. Radio signals would take about 11 minutes to travel from Earth to Mars. The spacecraft was pre-programmed to descend, maneuver, and pick a landing site on its own. All the work his colleagues hoped to do on Mars would be impossible if his part of the mission failed.
How long have you been working on this mission?
Coming up on 9 years or so.
Really? That's a lot of work for 7 minutes of
nine years of work, 7 minutes of terror.
It's done if the parachute doesn't work.
That's right. No one wants to be that the guy that drops the baton.
No landing by a spacecraft has ever been recorded as well as this one. There were 6 cameras capturing it all from different angles. The parachute deployed, then the heat shield fell away like a lens cap, and Perseverance got its first look at the ground. This is not a simulation. This is what it looks like to parachute onto Mars.
How fast is it moving at this point?
Yeah, we're still going about 350 miles an hour and still slowing down.
So it looks gentle here, but in fact, it's falling at more than 300 miles an hour.
That's right. We're heading straight down at near race car speeds.
Below lay a series of safe landing spots But the wind was blowing the spacecraft towards more treacherous territory to the east, and Perseverance sent a message to Earth saying the thrusters it needed to slow down might not be working properly.
So you get a reading saying the jets that are going to help it slow down and control the landing, that they're not working. So what do you do?
There's nothing you can do, right? Everything's already happened. That's the mind-bending part of this, right?
You are sweating now.
Yeah, exactly. I'm right back there again. So, yeah.
Altitude of about 300 meters.
To Al Chen's relief, Perseverance's computerized landing system did what it was designed to do. It found a suitable landing spot even in rocky terrain. And despite the warning, the thrusters worked. You can see them kicking up dust as they fire to slow the spacecraft down.
Sky crane maneuver has started.
The descent stage, known as the sky crane, lowered Perseverance to the ground. It hovered for a moment, then flew off to crash a safe distance away.
And there goes the descent stage.
Touchdown confirmed. Perseverance safely on the surface of Mars.
So at that point, big sigh of relief. I almost collapsed over this console.
For 2 months after the landing on the Red Planet, a team of engineers, programmers, and scientists here on Earth were living on Mars time. It's their job to monitor the rover's health and tell it where to go and how to search for signs of life. While Perseverance slept to conserve energy during the freezing Martian nights, the team on Earth analyzed the photographs and instrument readings it had sent back. They then prepared a list of things for it to do the following morning when it woke up.
And so it's just after midnight on Mars. The vehicle's asleep.
Project manager Matt Wallace explained that a day on Mars is 40 minutes longer than on Earth. The team's schedule was constantly changing.
So all the people here are Mars night shift workers.
Yeah, that's a good way to think of it, yeah.
But I mean, working night shift is tough enough, but this is a night shift that's constantly shifting.
Constantly moving, that's right, yeah.
On Perseverance's 4th day on Mars, it swiveled the powerful camera on its mast and took a look around. A space enthusiast named Sean Doran put the images together, set them to music, and posted the movie on YouTube. Even one of the top scientists on the project was moved when he saw it.
I went and got a beer and watched this thing scroll by. And that was the moment when I felt like I was there.
Ken Farley leads the science team that will direct Perseverance through the Jezero crater. It's an area that scientists have long wanted to search for signs of ancient life that may be hidden in the rocks.
The oldest evidence of life on Earth is about 3.5 billion years old. Those rocks were deposited in a shallow sea. This crater that you see here was a lake 3.5 billion years ago. So we are looking at the same environment and the same time period on 2 different planets.
And if it's determined, however long in the future, that no, there was not ever life, what does that mean?
The place where Perseverance landed, here in Jezero Crater, is the most habitable time period on Mars and the most habitable environment that we know about. This is as good as it gets, at least with our current understanding of what Mars has to offer. And if we don't find life here, it does make us worry that perhaps it doesn't exist anywhere.
Perseverance hasn't strayed far from its landing site yet, but its telescopic camera has already spotted a large number of boulders that Ken Farley says he didn't expect to see in the middle of an ancient lake.
So this has surprised you?
Absolutely, yeah.
So what did those boulders tell you?
The most reasonable interpretation is a flood. You don't have fast-flowing water out in the middle of the lake. You get fast-flowing water in a river. And so what that's telling us is there was a river that was capable of transporting boulders that were this big.
So what, the lake would have gone down perhaps, and then later on there was a flood?
Yeah, exactly.
Perseverance was supposed to leave Ingenuity behind after a 30-day demonstration of its flying ability. But NASA officials decided to keep the duo together longer to explore how rovers and helicopters might work together in the future. The fastest that Perseverance was designed to travel is 1/10 of a mile per hour. Ingenuity has already gone 80 times faster, according to project manager Mimi Ong.
Adding an aerial vehicle, a flying vehicle for space exploration will be game-changing.
It frees you in a way.
Absolutely, yes. So a flying vehicle, a rotorcraft would allow us to get to places we simply can't access today, like sides of steep cliffs, inside deep crevices.
After Perseverance explores the floor of Jezero Crater, it'll head towards what's believed to be the remnant of an ancient river delta. where billions of years ago conditions should have been right for microorganisms to exist. As this simulation shows, the rover's robotic arm can collect about 40 core samples of rock that'll be sealed in special tubes and left on the planet's surface. NASA plans to send another mission to Mars to retrieve the tubes and bring them back to Earth. In about 10 years, Ken Farley says, scientists examining those samples may be confronted with a new and perplexing question.
How do you look for life that may not be life as you know it? We've never had to do that before. We've never had to actually ask the question.
Is there a form of life that we can't even conceive of?
Yeah, we're going to have to conceive of it. I think that's the whole point of this. We're going to have to start conceiving of life as we don't know it.
If all goes according to plan, Perseverance will be making tracks on Mars for years to come. Since it's carrying the first working audio microphones on the red planet, we'll leave you with what it sounds like as the one-ton rover slowly moves across the vast, lonely expanses of Mars. Since our story first aired, China landed its first rover on Mars about 1,000 miles away from where Perseverance is located. China's National Space Administration has said it too plans to collect samples of the red planet and bring them back to Earth.
Now, the latest from Mars, thanks to NASA's incredibly sophisticated geologist, a one-ton rover named Curiosity that landed on Mars more than 4 years ago. Its biggest discovery so far is this. More than 3 billion years ago, Mars had all the building blocks necessary for life. Back then, Mars and Earth were very similar, wet, warm, and habitable. But as life evolved on Earth, Mars became cold, dry, and inhospitable. Did life ever exist on Mars? We don't know yet. But the rover Curiosity is on the hunt and has been slowly maneuvering through a topographic treasure trove. Tonight, you'll see stunning pictures and hear what Curiosity is telling us about Mars and Earth. From Mars, Curiosity can barely see Earth more than 30 million miles away. But Curiosity is seeing Mars as never before, leaving its mark, its tracks, and sending back postcards of sand dunes 20 feet tall, extending for miles, ancient stone lake beds that have been dry for billions of years, and time-lapse pictures of a Martian sunset. Like any vain photographer, Curiosity poses for selfies along the way as she works to solve Mars' most challenging mysteries.
So we're reading the rocks with Curiosity.
Reading the rocks.
We read the rocks.
Katie Stack Morgan, a geologist at NASA's Jet Propulsion Laboratory, helps decide what pictures Curiosity should take and where it should go. Hundreds of scientists and engineers support the rover. They can't drive it in real time from Earth because there's a 30-minute time lag to get a message to Mars and back. So Curiosity, shown in this NASA animation, gets its instructions beamed up at the start of each day. And the rover is such a talented geologist that it can teach us a lot from a single pebble fused into a bigger rock.
There's a pebble right here, and it's actually quite round.
And on Mars, round pebbles mean they used to be wet.
And if you think about pebbles that you find in a stream on Earth, they tend to be very round as well. It's because as they move in the streams, pebbles are hitting other pebbles, and they round off all the little corners. That's how we know this deposit was formed in rushing water. I mean, this is the first evidence we have from the surface that water flowed across the surface of Mars.
This NASA animation is based on Mars' actual surface. Curiosity's capabilities include a laser that zaps rocks up to 23 feet away to find out what they're made of. It's the first rover that can drill for samples of Mars and analyze them in its built-in lab. An early sample told us more about that water that used to be here and led to Curiosity's biggest find so far.
The water that was on the surface of Mars, you could scoop it up and drink it.
Rob Manning, chief engineer at JPL, told us Because the water was drinkable, and because Curiosity also found essential organic chemicals, Mars could have supported life.
Does that mean life was there? It doesn't. We don't know.
You're talking about microbial life.
Microbial, single-cell organisms. But if you would look for today alive, it wouldn't be on the surface. You have to go underground, just like we have life on this planet, huge amounts of life living underground on this planet.
Manning told us life might have traveled back and forth between Mars and Earth.
When a meteor comes along and hits Mars, a rock from Mars can be lifted up, travel then in circles around the sun until someday it will bump into Earth and land in, say, Antarctica.
Where a rock from Mars was discovered in 1984.
Right. We found Mars rock, and we found them all over Earth. And the reverse is also true. Certainly, Earth rock with life in it has taken a trip to Mars.
Could that life survive the trip?
We believe
30 million miles?
We don't know. We think life might be able to do that.
Get ready. Here's the punchline.
Could have been that Mars was habitable before Earth was, and life got its foothold on Mars and took its journey to Earth, and we're all Martians.
You know how mind-blowing that is?
But it's possible. Life is amazing.
Mars could have been habitable when Earth wasn't, because we're looking at rocks that are very, very old.
How old?
I mean, we're talking billions of years.
Why is it that we can't find rocks here that are as old as on Mars?
Most of Earth is constantly recycling as the plates on the surface move around. But here on Mars, we don't really have evidence for plate tectonics. This is the Mars rock record of Mars history preserved at the surface. And that's a really unique opportunity to explore a time in the solar system that may not be preserved on the surface of Earth.
The scariest part of the entire mission was Curiosity's landing on Mars. It couldn't bounce onto Mars cushioned by giant airbags the way smaller rovers had. Curiosity weighs a ton, too big for the bags. So lead engineer Adam Steltzner and his team came up with a bizarre plan to pack Curiosity into a flying saucer, fire rockets to slow its descent, and then use long cables to lower it onto Mars. Many here thought they were crazy.
The team recognized that if we failed, we would find no comfort or solace from the general public.
There'd be a lot of fingers pointed.
The man on the street says, that looks crazy. I could have told you it was crazy. And so I developed this little statement I would make before I'd even start. It goes like this: great works and great folly may be indistinguishable at the outset.
Because of the communication time lag, they could not direct the landing from Earth. The complex maneuvers were pre-programmed. Steltzner and his team could only wait and worry.
We were just sitting in the control room, pacing back and forth, trying to remember to breathe.
Here's animation of the landing. And the actual reaction at mission control.
Touchdown confirmed.
The team celebrated. And then sometime in the wee hours of the morning, I went home, crawled into bed with my wife, and wept because I was spent. I was overwhelmed.
This is where Curiosity landed, the smudges on the left. They look like burn marks, but they're not.
They're dust clearing marks. This is where the rockets cleared the dust away.
I see a trail.
That's right. So these are the tracks of the rover. So the rover landed here, and then it drove along, made a couple of turns, and you can actually see this from orbit, which is incredible.
NASA's been sending satellites to Mars for more than 50 years. 3 are orbiting Mars now, monitoring its weather and sending back images of giant craters, wind-carved ridges, and an avalanche of sand pouring down a mountain, kicking up huge clouds of dust. Down on the surface, one of the 3 earlier rovers continues to operate. Opportunity is just 1/5 the size of Curiosity. It can't scoop up samples or analyze the surface the way Curiosity can, but Opportunity has been snapping stunning pictures for 13 years, while Curiosity's mission almost ended after just 6 months.
The rover had some sort of memory problem.
Rob Manning told us a computer glitch came within 1 hour of stopping communication with Curiosity forever. The rover has 2 identical computers called Pilot and Co-Pilot.
The pilot is supposed to have enough self-diagnosis and be smart enough to say, I'm not doing very well, I'm not feeling well, I'm going to let the co-pilot take over.
Yet Pilot was not doing well and refused to give up control.
In fact, it started acting a bit like it had an attitude.
The computer had an attitude.
The computer's developed an attitude in a way that we've never seen before. When we told it to go take a nap, it refused to take a nap. Then it refused to take pictures. Then it refused to do more science throughout the day. It just stopped doing these things. I said, what the heck is going on?
And time is running out.
Time is running out because in an hour, it's going to turn its radio off and stay off forever, and we'll lose this very expensive rover.
Manning's team sent an order to kill the pilot, hoping that would force the co-pilot to take over.
We're waiting for the co-pilot to wake up and then turn on its radio to let us know that it was alive. We should get a signal. Nothing. Another minute goes by, nothing. 4 minutes go by. Now we're starting to get really worried.
It sounds like a movie.
It really was, it was getting nerve-wracking. And bing, there's the signal. And the backup pilot was obviously in charge. And so...
The backup pilot's still in charge today?
The backup pilot's still in charge. We have since repaired the bad pilot.
To help direct the pilot, the Jet Propulsion Lab built its own patch of Mars, where they can practice maneuvers with the rover's twin. Adam Steltzner told us the rover can see where it's going and make mid-course corrections to avoid pitfalls.
Why is she so slow? We are exploring. We don't want to miss anything. So she moves deliberately.
So Katie Stack Morgan can study everything Curiosity sees.
This is actually an active dune field.
What do you mean by an active dune field?
It means that the sand particles that are making up the dunes are still moving today.
Being blown across the landscape.
They're very slowly being moved across the surface.
Because of the Martian wind?
Mm-hmm.
Everybody we talk to talks about how studying Mars helps us better understand Earth. How so?
When we look at rocks on Mars, we are potentially seeing a snapshot of our solar system at a time before Earth developed its environment as we know it. It's really like we were there.
Now Curiosity has started climbing partway up Mount Sharp. That's why it landed nearby. The mountain is a layer cake of history, each ascending layer revealing how Mars changed over time.
The layers at the bottom, those are the older layers, and each successive layer is younger and younger and younger.
As you climb the mountain, what do you expect to find? What do you hope to find?
We're actually expecting to see that transition. When Mars transitioned from being a habitable planet to being one that was not habitable.
What happened to the atmosphere of Mars to turn it into this almost dead planet?
It cooled, it lost its magnetic field, the solar wind blew away its atmosphere, and so it dried out. It became a prune of its former self. We're still a plum, it's a prune.
What does that Martian history tell us about Earth?
I don't think we have to worry about drying out like Mars. But it does teach us...
That's a relief.
Right. But it does teach us of how delicate the balance of our environment is. And so it should heighten our appreciation of what a beautiful, warm, wet hug living here on Earth really is.
How many planets are there? 9 is what we were taught. But as telescopes get stronger and astronomers learn more about our solar system, long-accepted facts become fallacies. Pluto had been considered a planet for 76 years, but Pluto lost its planet status after an astronomer at Caltech discovered that Pluto wasn't so special after all. His name is Mike Brown. Brown and other astronomers have since found hundreds of large balls of ice like Pluto circling the sun at the far reaches of our solar system. Demoting Pluto leaves us with 8 planets. But Mike Brown is preparing another surprise. He is sure there is a real 9th planet way out far beyond Pluto. He hasn't seen it yet, but he expects to soon. He believes the real Planet 9 is huge, and it's out there.
I would say at this point, I am certain. Certain. Yeah. That's a rare thing to say for a prediction for a scientist, and I'm willing to say it.
You do know how mind-boggling this sounds. I mean, a new planet hasn't been discovered for
170 years.
I believe you think it looks like this animation over my shoulder here.
You know, we took a little artistic license and put some lightning on the dark side of it because it might have lightning on the dark side of it. We think that it's somewhere between 10 and 20 times more massive than the Earth.
And we haven't seen it? We can't see it?
It's so far away that it's actually just at the edge of what our biggest telescopes on the ground can possibly see because it's so far away.
50 billion miles away. It's also hard to find because it has an enormous orbit.
Planet 9, we think, takes something like 15,000 years to go around the sun.
Wait a minute, 15,000 years?
15,000 years.
To make one orbit?
One orbit.
To search for Planet 9, Brown goes up Mauna Kea, the big mountain on Hawaii's Big Island, to use the big telescope, the Subaru. Brown doesn't look directly through the telescope. He monitors pictures it's taking of the same sections of sky on successive nights, and then compares them, hunting for movement.
We have to very systematically look at every patch of sky here, 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 here. And what we're looking for is it's actually kind of simple. We take a picture one night, we come back the next night, all the stars, all the galaxies are in the same spot night after night after night. And Planet 9, when we see it, will slowly move across the sky.
And will look something like this. Brown's discovery 11 years ago that changed the way we think of the solar system. Using pictures from successive nights, Brown discovered this Pluto-sized object, which led to the demotion of lovable Pluto. You didn't love Pluto growing up?
I loved Pluto. I was totally fascinated by Pluto. When I started in astronomy, I started looking at this region of the sky because I thought it was so interesting out there.
When Pluto was first discovered, it was thought to be a big planet.
You can go back and find the New York Times headline on the day that the discovery was announced, and it says, a 9th planet discovered in the outer solar system, possibly larger than Jupiter.
Jupiter's the biggest planet, but Pluto, it turned out, was no Jupiter.
These are all the planets and other objects at their real relative sizes.
This is Jupiter.
Jupiter is huge compared to the other things. This is Jupiter. This is Saturn without its rings. Uranus, Neptune, Mercury, Venus, Earth, Mars. And at the very edge of the solar system, as we now think of it, is Pluto. It's only wrong by a factor of 50,000.
So it went from being a monster planet to being a dwarf planet.
A dwarf planet, one of many that are out there that are part of this region of the sky.
This region is the Kuiper Belt at the edge of our solar system, a vast realm of frozen debris created during the birth of the solar system 4.5 billion years ago. The Kuiper Belt keeps Brown up all night, hunting for discoveries.
It's the most exciting thing I can think of doing. You know, it's not just that it's hard to stay up all night and so I force myself to do it. I am excited every night I go out there about what I might find.
When Mike Brown found that Pluto-sized object, it was the biggest of a group of hundreds of Pluto-like objects recently discovered. So Brown wondered, should Pluto really be a planet? But demoting Pluto would mean that every textbook showing planets would have to be changed. That was fine with Brown, who believes planets must be significant and that the 8 large planets are. Their strong gravitational fields control everything around them.
Planets are the big bullies of the planetary system that basically ignore everybody else around them, and everybody else has to deal with the planets. Those are what the planets are.
And Pluto didn't fit that concept.
Neptune controls Pluto's orbit. Neptune is the bully of that neighborhood.
To resolve the issue, astronomers from all over the world gathered in Prague in 2006. The International Astronomical Union would decide whether to demote little Pluto or give planet status to hundreds of similar objects.
6A is concerned with Pluto and Pluto-like objects.
Astronomers voted overwhelmingly to go down to 8 planets, and Brown became known as the guy who killed Pluto.
I think that's probably true.
The Pluto vote was ill-timed for NASA. Just 7 months before Pluto's demotion, NASA launched a mission to Pluto to learn about its surface and origins. Scientists are still analyzing spectacular pictures from NASA's flyby. They show Pluto's mostly icy surface and close-ups of craters. Now the spaceship is heading deeper into the Kuiper Belt. Although Pluto was demoted 10 years ago, Pluto lovers still send Brown hate mail and voicemail. He kept this one.
Hey, Pluto's still a planet, you jackass.
Even Brown's 11-year-old daughter, Lila, didn't like what he had done to Pluto.
What did you tell him that he should do to make up for that?
Well, I told him that if he found a new planet, it might make up for the fact that he killed a planet that everybody loved.
Seems that he actually went out and did that.
Yeah.
What do you think of that?
It's really great. I'm very proud of him.
She's referring to the huge Planet 9 we mentioned earlier. No one was more surprised by that discovery than Brown himself. Until recently, he believed our planets would only be the big 8.
And we had explored so much of the solar system beyond those 8 that if there were anything else like a planet, we would have found it.
After all, NASA's spaceships have flown past every known planet, capturing pictures of Saturn's rings, the pockmarked surface of Mercury, the gassy atmosphere of Jupiter. And well beyond our solar system, the Hubble telescope is busy taking pictures of distant galaxies. NASA says this single image shows 10,000 galaxies. Other pictures show signs of black holes millions of light years away. And this one, a glimpse of stars being born. No wonder Brown had thought we'd found all our planets.
So now you think there's another pretty big planet out there?
Yeah, I am pretty dead certain that it's out there.
What makes you think that?
As we were studying these objects out beyond Neptune, Pluto and the other objects in the Kuiper Belt, but when you get to the most distant ones, they all look like they're being pulled off in one direction.
And you think the thing that's pulling them is a big planet?
Yes.
Couldn't there be some other explanation?
We tried many different explanations trying to prove that it wasn't a planet. Nothing works.
I am 100% convinced.
Brown's partner, Konstantin Batygin, a planetary science professor at Caltech, came up with this mathematical proof. Proof, he says, that Planet 9 is pulling those remote objects in similar oblong orbits. It looks like mathematical gibberish to our untrained eye, but Batygin told us his equation melds 10 accepted formulas, and when coupled with more than 8,000 lines of computer code, it describes Planet 9's orbit. So, he says, he doesn't have to see it to know it exists.
The mathematics proves it. And it's like being, downtown and hearing an ambulance a few streets away. You haven't seen it, but your other senses provide you with the information that really this ambulance is really there. Here, instead of hearing it, you see it in the math.
This is a roadmap to Planet 9.
Exactly. This, in the end, tells you where to look on the sky.
To speed up the search, Batygin and Brown published their roadmap so other astronomers could join the hunt. Foremost among them is Scott Shepard of the Carnegie Institution. It was Shepard who first spotted the odd orbits in the Kuiper Belt that led Mike Brown to conclude there's a huge planet out there. Now Shepard, like Brown, compares the pictures taken on consecutive nights, hoping to spot Planet 9.
We just found some more of small objects very far in the solar system that continue to show the trend that there should be a Planet 9 out there.
Is it important to you whether you were the first to find it or another astronomer finds it?
It'd be great to be the first one to find it. It is a race. There's a lot of people looking for it. But just to have it found is what we want.
When do you think we might actually spot Planet 9?
I think that within 3 years, we will be able to cover that swath of sky that we need to cover.
Is this giant Planet 9 the last planet we'll find in our solar system, or is there a Planet 10?
Yeah, we don't know. Planet 9 is already far enough away that it requires the biggest telescopes we have to find it. Planet 10 is even further. Planet 9 is our generation's planet. It's the perfect planet to find right now. Planet 10, this is when I talk to kids, I tell them, Planet 10, it's yours. Go find it.
President Obama canceled NASA's plan to replace the Space Shuttle in favor of a more modest program, and then Congress slashed the funding for that. So, for the first time in 50 years, America is not the leader in spaceflight. Fact is, we couldn't launch an astronaut today if we had to. With the end of an era, we wondered what would happen to the generation that put America in space. So last July, when the smoke cleared from the last Space Shuttle launch, we stayed behind in Brevard County, Florida, the home of the Kennedy Space Center. What comes after reaching for the stars? For many in Brevard County, the answer is a hard landing.
All 3 engines up and burning.
There was nothing like it in the world.
0 and liftoff, the final liftoff of Atlantis.
Arguably the greatest engineering achievement of man. At liftoff, it weighed 4.5 million pounds. Its top speed, 17,000 miles an hour.
The Space Shuttle spreads its wings one final time for the start of a sentimental journey into history.
It was built by the hands of people like Lou Hanna.
It was the experience and the job of a lifetime. I was working on a pad one day with a friend of mine, and he's a crane operator too. And I asked him, I said, how many other crane operators do you suppose that there are doing what we're doing? There's 2, you and me.
Shuttle work wasn't just work. There was enormous pride in doing for America what no other workers in the world could even dare. Lou Hanna manned a gigantic crane that cleared the platform before launch. He worked on the first shuttle in 1981.
America's first space shuttle.
And the last, 135 missions later.
What did seeing the last shuttle launch mean to you?
I felt anger.
Anger?
Oh, yeah, because this does not have to be the last launch. It doesn't have to end this way. I mean, it just doesn't make any sense. It doesn't compute, and I guess I'm still in denial because I'm thinking they're going to call me back one day. We got a launch coming up. We need your help. How can they do that?
They did it to save $3 billion a year. Now, the only way an American can fly into space is to buy a seat on a Russian rocket. At the Kennedy Space Center, 7,000 workers lost their jobs.
Main gear touchdown. The space shuttle pulls into port for the last time.
50 years of liftoffs are becoming 8 months of layoffs. Have a look around Brevard County. It's shrinking. Lots of people are moving away, taking businesses down with them.
It was like, bam, gone, gone, gone.
The work ethic that built the shuttle keeps Chris Milner fighting to hang on.
How long did you work at the Space Center?
8 years.
And your wife?
29 years.
Both laid off?
Both laid off.
In the spirit of an entrepreneur, Milner planned for the layoffs. 5 years ago, he launched a landscape business on the side, and then he added a sign shop in this industrial park. Still, there was one thing he didn't plan on.
Seafood is gone, and there's nothing there. Edwards Exterminating is the only one that's left. It's right around the corner. But basically, everything's empty. It's a nightmare. Everybody's been laid off. It's a ripple effect. Businesses closing down, and it affects everybody else, and it affects me.
The 7,000 layoffs at the Space Center triggered 7,000 more in the community. Unemployment has been close to 11%.
People are moving away. People are going up north. Nothing's happening here. I know people move all the way to Seattle for a job, left their house, left the key in the front door. Here you go. It's gone.
Milner had 12 employees in the lawn business. Now he has 3.
You know, you're running these 2 businesses.
Yes.
How many hours a day are you working?
Literally.
Literally.
I'm here at 7 a.m. in the morning, and in the last couple of weeks, I've been here until 1, 2 o'clock in the morning. My last day off was Christmas.
Working 17 hours a day, 7 days a week.
Yes.
Can't be all that good for your health.
No. My wife's worried. She's scared. She's told me that.
And she's taken out a life insurance policy on him.
But at the same time, she knows what I got to do. And the problem is we have a 12-year-old at the house that doesn't understand because he's never had to go without. He's constantly asking for McDonald's. We don't get McDonald's anymore.
That's beautiful.
This isn't the first hard landing on the Space Coast. There were big layoffs in 1972 after the last mission to the moon. But here's why today is worse. When we left the moon, NASA was already years into designing the shuttle. And it looked like it would be that way now, because President Bush approved a program to follow the shuttle.
The new manned space program rocket was supposed to be called Constellation, and now you guys call it
Cancellation. Unfortunately.
Lou Hanna and Joe Urich, Holly Petrucci, and Mike Carpenter planned to transfer from Shuttle to Constellation. They were encouraged when candidate Barack Obama came to Brevard County in 2008, 3 months before the election.
I'm going to ensure that our space program doesn't suffer when the shuttle goes out of service by making sure that all those who work in the space industry in Florida do not lose their jobs when the shuttle is retired, because we can't afford to lose their expertise.
Well, we were lied to when Obama came through. Gave us a lot of hope and supposedly a lot of change. Well, I've got change in my pocket, but the hope is gone.
In 2010, President Obama canceled Constellation and turned over development of a new spaceship to private enterprise. Then, Congress dealt another blow by cutting the funding for the Obama plan in half. At the very least, it will be 5 years before America flies astronauts again. Now, the workers with that expertise Mr. Obama referred to are setting course for Carol Bess.
And I've had several who've told me, I was considering suicide before I came to you.
Carol Bess is a bankruptcy attorney.
What drove them to that point?
They feel like failures. You know, here I am, I can't pay my debts. And I'm probably worth more dead than alive if I have life insurance.
And folks either aren't finding work, or if they do, they're making a lot less than they were before.
Correct, and that's not going to change. These people have no hope. It could still get a lot worse, I think.
Following the Great Recession, we visited a lot of communities that lost their main employer, but never one like Brevard County. We learned about the sense of loss with our first question to Lucas Maxwell, who used to handle the dangerous fuel for the rockets.
What was it like when it was launched? Paint that picture for me.
Awesome. No.
The thought was too much for a moment. Then he came back to tell us why.
Made your heart stop. It's awesome, no matter what. You know, the pride that goes into a vehicle like that. But I knew it was the end, too. You know, I knew I was going to be out on the street.
And Space Shuttle for you, I have the sense, was a statement about the country.
Oh, yeah, absolutely. This is a matter of national pride.
The end of the shuttle is threatening businesses that families have built over decades, like Shuttles, the first bar you come to leaving the Space Center. Not just a bar, really. It's the place where astronauts land. In July, before the last launch, we stopped in to see owner Bill Grillo.
How many employees did you have at the peak?
We had 25.
And now?
We're down to 8.
And you're one of them?
Yeah. If it comes down to just myself, my son, and a cook, we'll hang on. Shuttles will be here. I won't let it go.
7 months later, this is Shuttles today.
I'm sorry about this. When we were here before, you were optimistic. You said this place wouldn't close.
Yeah. Within 45 days after the last shuttle, we lost 70% of our business. We weren't able to sustain. As much as it killed me to do that, I had to.
And you've been gone for a couple of months now. But I don't think you've moved a thing in here.
I can't right now. It's too painful to do that. I got a lot of my heart is here, and I can't take anything off the walls yet.
It's not just a business.
No. No, this is an institution. And I don't want to be the one that takes it apart.
No one we met back in July expected to be the one to take apart the life they'd known. Some were the second or third generation in their family to work at the Space Center. Before the last launch, we met several at a job center applying for the remaining aerospace work. Sammy Rivera worked on the shuttle 26 years, reviewing engineering drawings.
I figured the day I wake up dead, I won't go to work. It's the bottom line. There's not going to be anything for me to retire on.
We caught up with him today.
You didn't expect to be unemployed 11 months and counting.
At the max, I figured 3 months. I've applied for engineering jobs. I've applied for technician jobs. I've applied for entry-level jobs.
Have you had any interviews?
3.
Total of 3?
Total of 3.
3 interviews in 11 months?
Yes, sir.
Do you have health insurance?
No, sir. No, sir. My health insurance terminated on my last day of employment.
How are you getting along?
A lot of prayer. The medications that I was on, out-of-pocket expense, runs me over $800 a month. With no money coming in, I can't afford that.
So he's taking only one of the 2 pills that his doctors say he has to take to avoid a heart attack.
You know when you're raising that flag in your front yard?
Yes, sir.
What are you thinking?
This is my country, and I can't let it go down without a fight.
The 4 remaining shuttles are headed to museums. Atlantis will be on display at the Kennedy Space Center. She was designed for 100 missions, but flew only 33. Like so many in Brevard County, Florida, she was pulled from the service of her country long before she was ready.
For decades, the U.S. has relied on spy satellites to look deep inside the territory of its adversaries. These giant billion-dollar satellites take high-resolution photographs which can see objects as small as a fist inside Russia, North Korea, or wherever the target is. Tonight, we will take you inside the intelligence agency where those photos are analyzed. And we will also take you inside a revolution that is rocking the top-secret world of spy satellites. A private company named Planet Labs has put about 300 small satellites into space, enough to take a picture of the entire landmass of the Earth every day. Those small satellites have created a big data problem for the government, which can't possibly hire enough analysts to look at all those pictures. Welcome to the revolution.
5, 4, 3, 2,
1.
This is how the revolution began. 28 small satellites sent out into orbit by astronauts from the biggest of all satellites, the International Space Station.
We took a satellite that would be the size of a pickup truck and we shrunk it. We wanted to make it about the size of a loaf of bread.
Robbie Shingler began building satellites 20 years ago, working for NASA.
The way that I grew up at NASA is we would spend about 5 to 10 years even to build one satellite.
Now he's one of the founders of Planet Labs.
This is our satellite manufacturing building.
A company that turns out satellites in months, not years.
You can pick these up. They're about 12 pounds or 5 kilograms.
Packed with some of the same electronics used in smartphones, they're built by hand in a nondescript building in downtown San Francisco.
It looks like a warehouse, and our engineers here build and operate the largest fleet of satellites in human history.
It's a pretty big statement, the largest fleet of satellites in human history.
I know, isn't that cool? And frankly, we're just getting started.
How many have you built over the years?
Oh, over the years, we've built about 300 satellites over the years. And last year, we launched about 146 satellites into space.
The satellites are called doves. Here on the production floor, they are kept in nests, waiting to be launched in flocks.
This is a visualization that shows every satellite that we have up in space today.
This is mission control?
This is mission control, yeah.
It's a little bit of a letdown.
But it's a little bit non-traditional. A normal mission control, you will have dozens and dozens of engineers for one satellite. We flip that around. So we have dozens of satellites for a single engineer.
The satellites orbit the globe every 90 minutes while the Earth rotates beneath them. Their cameras documenting the planet as it's changing.
I'm always astonished that almost every picture we get down, we compare it to the picture from yesterday, and something's changed.
Will Marshall is another of the company's founders.
As we see rivers move, we see trees go down, we see vehicles move, we see road surfaces change, and it gives you a perspective of the planet as a dynamic and evolving thing that we need to take care of.
Is that what people are supposed to conclude from seeing all this change?
Well, you can't fix what you can't see.
2, 1.
That kind of save-the-world ambition carries a big risk, especially for a small firm that's just getting started.
And we have liftoff.
The planet has many records. We've launched the most satellites in the world ever, but we've also lost the most satellites ever.
4 years ago, Marshall gathered his staff in what Planet calls the mothership to watch a rocket carrying 26 doves blast off.
It was a big deal, and we had a customer in the audience at the time that we had brought to see a launch. It was really embarrassing.
Oh, God. Oh, God. Oh, God. Hold on.
I'll never forget it. We see the, smoke coming and everyone's cheering, ah, and then it goes and then kaboom!
Chester Gilmore runs Planet's satellite assembly line. You lost how many satellites?
26.
26.
I think we lost, 26.
Those are your babies.
It was a tough, they were.
How long did it take you to get back to normal?
We didn't even skip a beat when that happened. Didn't lose a day.
On the day we visited Planet, its satellites were beaming down 1.2 million pictures every 24 hours. Planet sells images to over 200 customers, many of them agricultural companies monitoring the health of crops. But this is Planet's most important customer.
So this is our operations center, heartbeat of the agency.
Robert Cardillo is director of the National Geospatial Intelligence Agency, NGA for short, the organization which analyzes satellite photos. So this really is ground zero for all the intelligence coming in from space.
That's correct. It's where we bring in all of our sources, whether they come from space or any source, but correct, it's ground zero.
Because 60 Minutes was allowed into this secure operations center, top secret high-resolution pictures taken by spy satellites are nowhere in sight.
Across the center,
Cardillo says lower resolution images like this one taken by commercial satellite companies.
You see one of the outposts that the Chinese have developed in the South China Sea.
Are changing his world by giving him more and more looks at the Earth, especially places U.S. spy satellites are not zeroed in on.
I'm quite excited about capabilities such as what Planet's putting up in space.
Planet is a small company with just over 400 employees, many of them in San Francisco. NGA is a government bureaucracy with a workforce of 14,500 and a 2.7 million square foot headquarters south of Washington, D.C. But Robert Cardillo knew a revolution when he saw one.
This is not the scale model. This is the real size.
When Planet's Will Marshall unveiled his small satellite at a 2014 TED Talk, Cardillo showed the video to his workforce.
It's going to provide a completely radical new data set about our changing planet.
And a radical new culture.
Thank you.
Planet openly markets its images. NGA's spy photos rarely see the light of day. The intelligence analyst who leaked these photos of a Russian shipyard in 1984 went to prison. What NGA can see from space is top secret.
How many of these high-resolution satellites do you operate? I'll not comment.
But much of what Cardillo won't talk about is common knowledge to Ted Moxon, who is a household name in the obscure world of amateur satellite tracking.
How many photo satellites does the U.S. have in orbit?
Currently, there are 3.
Liftoff of NROL 71 for the National Reconnaissance Office.
Since we interviewed Moxon, what looks like a 4th photo satellite has been launched. He tracks them from his balcony in downtown Toronto with nothing more sophisticated than $300 binoculars.
You just wait for a flyby from the satellite?
Yeah, I'm laying in wait.
For something that's 150 miles away, going 5 miles a second.
Yes, yeah, and it will cross my field of view in a few seconds, so I've got to be on the ball.
Here's what a top-secret satellite looks like from Earth, captured on video by one of about 20 amateur trackers around the world.
Its code name is Crystal. This thing is about the size of a city bus.
And this is what it looks like from Earth.
That's right. It just looks like a moving star.
The satellite trackers watch as it streaks across the sky, measuring its position against well-known stars.
But that's enough to tell the orbit of the satellite.
Yes, we're doing this with our eyes, often with cameras, but the end result of it is numbers. And if we pool enough of that data together, we can actually calculate the orbit to great precision.
If you've been able to calculate this, presumably the North Koreans have been able to calculate this.
Absolutely, yes.
So there's no mystery to the North Koreans, the Russians, the Iranians, the Chinese, when these satellites are overhead taking pictures.
That's right.
It's space-age hide-and-seek. Adversaries know when and where American spy satellites are looking, but can never be sure what they're finding.
This is what NGA developed in the pursuit of Osama bin Laden.
Before President Obama and his national security team, including Cardillo there on the left, gathered in the White House Situation Room on the night of the raid, NGA had gone back in time through 7 years of satellite imagery to construct this scale model of bin Laden's hideout.
We had historic imagery of this compound that enabled us to reverse time.
NGA could see not just the outside, but inside as well.
It enabled us to go back to the point of construction and essentially, through our imagery archive, to rebuild the house. So we could see how the first floor was designed and how the rooms would lay out, where are the stairs from the first to the second floor and the second to the third floor.
So old pictures showed that building before the roof went on.
We had pictures before the compound existed. We saw it when it was first constructed and as it was built over time, correct.
And that's how you could find out the dimensions of each room.
Indeed.
The satellites that made that possible are the equivalent of a Hubble Space Telescope. But instead of taking pictures of the heavens, they are zeroed in on Earth, able to make out objects just 4 inches across.
Keel camera on monitor 2 for me.
For decades, they have been indispensable to knowing what America's adversaries are up to. But like Hubble, they cost billions of dollars each, which is one reason there are so few in orbit.
Are they putting more up?
They've never had more than 4 up at a time.
Which is why Cardillo is so interested in Planet and its small satellites that deliver a tsunami of data like NGA has never seen.
How many analysts would it take to keep up with those number of satellites? We did some calculations, and we came up with 6 million humans would need to be hired to exploit all the imagery that we have access to. You can see that it's not exactly a viable proposition.
If you were trying to find this in Syria, it's sort of like a needle in a haystack, right?
Planet's Shauna Wolverton showed us how a computer can be programmed to help track the impact of Syria's civil war on the people who live there.
So what we've done is created an algorithm that looks for new roads and buildings.
An algorithm that rifled through reams of satellite photos and identified the first signs of a new refugee camp.
Here's that first image.
So the red grid is what?
Those are new roads, and all of these blue spots that you can see here are buildings.
So this is one little corner of Syria. Could you do this for the entire country?
We could absolutely do this for the entire country. I can show you over here. We can zoom out. And you can see that we've run this algorithm over the entire country, and you can see all of the roads and buildings.
This is the first photo an American spy satellite ever took from space in 1960, a far-off look at a Russian airfield. Since then, we have gotten much more spectacular looks at Earth, like these taken by the Apollo astronauts. But the U.S. government no longer holds a monopoly on photos from space and has no power to stamp top secret on any of the 800 million images Planet has taken in its brief lifetime. Making it available to everybody, people are going to come up with uses of that imagery that you haven't imagined.
Dreamed of, yeah.
And not all of them are going to be good.
No.
You worry about that?
I worry a lot. And we wouldn't have started Planet if we didn't have a very strong conviction that the vast majority of the use cases are very, very positive.
This December 22nd may become known as the day the universe changed. That Wednesday, NASA expects to launch the James Webb Space Telescope, the largest and most expensive instrument ever flown. 100 times more powerful than the 31-year-old Hubble telescope, Webb can see back in time all the way to the let there be light moment, that instant when a cold, dark universe ignited into stars.
Wow. Well, somehow that's a lot bigger than I imagined.
She's a big one.
A year ago, we were among the last humans to see the telescope, much as it will appear in space. After our visit, it was packed away for a journey of 1 million miles, far beyond the moon, to lie forever in the grasp of the sun. The operating life is how long?
It's designed for 5.5 years with a goal of 10 years. So that means we carry enough stuff on there to last for 10 years.
Amy Lowe is a systems engineer who took us up in the clean room at Northrop Grumman in Redondo Beach, California.
We had to invent it, design it, build it, and hand put it together.
At the bottom of the spacecraft, that silver shroud is a parasol, big as a tennis court, to shield Webb from the sun. Above, there are 21 feet of gold-plated mirrors, 6 times bigger than Hubble's mirror, to catch the earliest starlight in creation. There are 18 of these hexagonal mirrors, but when you fold them out, they all work in concert as one mirror.
That's right. All 18 images will form one very nice, solid image.
That image would be invisible to the human eye. Like a night vision camera, Webb is designed to see heat, infrared light, because that's the only signature left from the stars at the edge of time. Even that glow will be so dim, the mirrors will have to squint for hours to expose an image. How much confidence do you have?
My job is to worry. I personally feel confident that we have thought of everything.
Thinking of everything took more than 25 years and $10 billion. Engineer Amy Lowe explained the challenge.
In my mind, the biggest engineering challenge was to build a sun shield capable of shielding the optics, the mirrors, and the instrument on Webb. How do you build something big but lightweight?
The sun shield keeps Webb cold and dark. Any infrared heat from the sun or Earth would blind the telescope. The 5 layers are made of gossamer sheets not unlike Mylar birthday balloons.
The layer facing the sun is layer 1, and layer 1 reaches about 230 degrees Fahrenheit, so a pretty warm oven, like if you wanted to cook a meringue or something.
And on the telescope side?
On the telescope side, it gets to negative 370 degrees Fahrenheit.
There's a roughly 600-degree difference
There is.
between one side of the heat shield and the other.
Yes, it's amazing that it's able to do this with nothing more than these layers.
The engineering is amazing, but the science may reveal the universe. Since the beginning, the Big Bang, the arrow of time has flown nearly 14 billion years. Webb may see all the way back to the first 100 million, the baby universe.
Powerful telescopes.
Amber Strawn is an astrophysicist on the project.
Telescopes really are time machines. They literally allow us to see into the past. And the reason for that is just due to the nature of how light travels. Light from the sun takes about 8 minutes to get to the Earth. So we're seeing the sun as it was 8 minutes ago. And you can sort of think about stepping that further out into the universe.
So when we walk out under the stars and look above us, we're not seeing the stars as they are today. We're seeing them as they were perhaps millions of years ago.
Absolutely.
Because it took that long for the light to reach the Earth.
Yes, for sure.
How much do we know about the universe?
Everything we know about, everything we can see, me and you, everything on the planet, all the hundreds of billions of other galaxies, all of that only makes up about 5% of the universe. The rest of it, that other 95%, we have no idea what it is.
That 95%, the unknown, is all around us like a ghost. Nearly all the cosmos is made up of what physicists call, in desperation, dark matter and dark energy. Never seen, scientists infer they must exist because they're the best explanation for how galaxies form and move.
So we know that dark matter is sort of the scaffolding of the universe. It's the structure on which galaxies sit. And if there wasn't dark matter, there wouldn't be galaxies and there wouldn't be us.
What might the Webb telescope reveal about dark matter?
It's like we have this 14 billion year old story of the universe, but we're missing that first chapter. And Webb was specifically designed to allow us to see those very first galaxies that formed after the Big Bang. Now, galaxies are born and then they evolve, they change over time. And this way that galaxies change must rely critically on dark matter. And Webb is going to allow us to observe that process of galaxy evolution in much more detail.
The promise of discovery shielded Webb on what's already been a treacherous journey. It was to launch 7 years ago, but delays come with a machine this ambitious. Because of cost overruns, Webb was canceled in 2011 by the House Appropriations Committee, but it was saved in the Senate. Its namesake is James Webb, head of NASA in the 1960s, who made science a top priority. What are the stakes? What's riding on that rocket with Webb?
When you talk about what's at stake, it really is NASA's reputation to take on a mission that is as challenging as Webb and be successful.
Bill Oakes and Greg Robinson run the program. Oakes was an engineer on Hubble. Robinson has supervised NASA quality and performance.
If you want to be bold and get the kind of science we're after, you have to make the investment. And it's going to answer two big questions for astrophysics. Where did we come from, and are we alone? And we're looking forward to getting those results.
Is Webb going to work?
Yes, it's going to work. I have very high confidence.
I'm 100% confident.
Why 100% confident?
Because when I look at the testing that we have done over the years and the type of engineering that went into it, you build a sense of confidence that you know it's going to work.
What are you most concerned about?
Unfolding the entire telescope is what you worry about.
The observatory had to be folded into an Ariane 5 rocket just 16 feet wide. It's wrapped today tight as a rosebud. In flight, more than 40 systems must blossom with perfection, including Amy Lowe's never-invented-before sunshield. All 5 layers will be folded up and held in place by pins. How many pins are there?
There's 107 of these membrane release devices and pins that hold all 5 layers pinned to this structure here called a UPS. All total 107.
And as you're unfolding, how many of those can fail?
None.
None?
None.
Not one?
Not one.
There is literally no room for error.
We test and we do a lot of analysis to ensure that each and every single one of these will release on orbit.
$10 billion rides on those pins. The Hubble telescope, 340 miles up, could be reached with a wrench. Webb, at 1 million miles, is beyond repair. Bill Oakes told us that if something does get stuck, there is an emergency plan.
We've developed algorithms to essentially, we call it the shimmy. We do a little shake on the telescope and we can rock it back and forth. If that doesn't work, we have another one we call the twirl, which can actually spin the telescope either clockwise or counterclockwise to help shake things loose.
So you're going to do what I do with devices when they're not working, you're going to shake it.
Yeah, can I do the same thing? Yes.
If 107 pins release, the mirrors synchronize, and 10,000 things go right, Webb will be limited only by about 10 years of fuel for pivoting and pointing. Canada contributed the aiming system that will guide Webb to wonders far and near. More than 1,000 astronomers around the world are competing for telescope time. Heidi Hamel was granted 100 hours.
I have so many questions. My particular focus is objects in our solar system.
Hamel told us that light is full of information. Webb can define the chemistry of a place by analyzing its wavelengths of light.
What is the atmospheric water content of Mars, and how does it change with time? What drives the chemistry in the upper atmosphere of Neptune? Can we see if there's water coming out of the moons of Jupiter or Saturn? There are just an infinite number of questions I want to answer.
Astrophysicist Natalie Battaglia also has time on Webb. She'll be looking at planets beyond our solar system.
On average, every star in the galaxy has at least one planet. That means that there are more planets in the galaxy than there are stars. Hundreds of billions of planets.
And with that many planets, Battaglia is sure Webb could find some with the chemistry and conditions of life.
There happens to be one planetary system. The star has 7 planets orbiting it, and the star is only about 40 light years away. So it's a great target to study, and it has 3 Earth-sized planets orbiting in what I would call the Goldilocks zone, where life could potentially exist.
Not too hot, not too cold.
That's the idea, yes. And so this is also one of the very first targets that we're going to observe with Webb. And what we'll be able to see is there carbon dioxide in the atmosphere? What are the greenhouse gases? Is there carbon dioxide in combination with methane? Because that's what Earth has. So by looking at these chemical constituents, we might be able to piece together if it's not just a planet in what we call the habitable zone, but if it's truly a habitable environment.
And somebody might ask, why does it matter?
The end point is to put an end to our cosmic loneliness. We want to know if there's life out there.
From a researcher's perspective, is Webb evolutionary or revolutionary?
Every time you put a new piece of technology into space, or you look at the universe with different eyes, you learn something revolutionary, something that you couldn't have even predicted. I don't know what those surprises are going to be, but the technology is revolutionary, and there will be tremendous surprises that will astound us.
Webb is on the doorstep aboard a European Space Agency rocket. Some, including Amy Lowe, may hold their breath as it unfolds itself on the month-long journey to its station around the Sun. The first images, in 6 months or so, will be converted from invisible infrared into pictures suitable for headlines. Chances are what we see we will not understand, the very definition of wonder.